Hello there and welcome to the Sleepumentary channel. There are nights in the far north when the world feels as though it has paused its breathing. Snow lies unbroken, the forests stand still, and the cold settles into every crevice of the land like a patient tide. On those nights, if you look upward long enough, the darkness begins to loosen. A faint glow touches the horizon, subtle at first, like the memory of daylight returning to a place it had long forgotten. Then slowly the sky begins to move. So before we continue, hit like and subscribe so you don't miss a single revelation as this story unfolds, moment by moment in real time. Tell me in the comments where you're watching, from what time it is there, and whether you believe we're hearing the whole truth about what's unfolding above our heads. And if you want to keep the signal alive, share this video on X, Facebook, Reddit, or even just with the people who still look up at night. You are the reason we can keep following the impossible, and for that, thank you. It begins with a soft green shimmer as if someone had brushed a luminous hand across the night. Then the glow gathers itself, stretching from one horizon to the other, rising into long, silent rivers of light. They twist and coil their edges, feathered by currents no wind on Earth can feel. The northern lights drift into being not as a flash, but as an exhale, a quiet signature at the boundary between Earth and the sun. People have watched this wonder for thousands of years, standing in the same frost, under the same slow moon, feeling the same tug of awe. Before science explained the story written above them, they turned to legend and imagination. To the Sami of Scandinavia, the aurora was the breath of spirits. To the Norse, it was the gleam of Valkyrie shields on their midnight ride. Inuit families told stories of ancestors playing across the sky, their laughter carried in streaks of faint light. And even those who had no name for it still felt something stir inside them, a sense that the heavens had opened a door. Tonight you're invited to stand in that same stillness, to feel the cold settle gently on your skin, to breathe slowly as the silence thickens around you. Above, the great arc of the sky begins its quiet transformation. The stars, once sharp and steady, soften behind a curtain that shifts as though alive. Green begins to deepen into a richer glow. A ribbon unfurls, a second follows. Soon the whole sky ripples like a vast ocean seen from beneath each wave, a pattern of faint glowing fire. And yet, for all its grandeur, the aurora begins far from here, millions of kilometers away, inside the heart of our star. High within the sun, magnetic fields twist and tangle like ropes pulled too tight. When they snap or rearrange, they fling charged particles outward in great streams. Some bursts are small like sparks, others are immense like the breath of a furnace rolling across the solar system. These streams travel outward for days, invisible and unstoppable, until they reach the quiet blue sphere of Earth. But the meeting is not violent. Instead, it is delicate, an interaction shaped by invisible forces that wrap around our planet. Earth's magnetic field stands like a guardian, guiding the solar particles away from most of the world, funneling only a fraction toward the far north and far south. There, near the magnetic poles, the particles slip into the highest parts of the atmosphere, brushing against oxygen and nitrogen atoms waiting silently in the dark. Each collision is tiny, quick, almost unnoticeable on its own. A single atom takes in a bit of energy, becomes excited, then relaxes and releases that energy in the form of light. One atom glowing would be nothing more than the faintest pinprick. But trillions of collisions happen each second. The sky becomes a tapestry woven from these microscopic sparks, like countless lanterns flickering in unison, each lighting the next. From the ground, you see only the final result, vast curtains of green and red and violet drifting across the night in shapes that seem to breathe. But behind the softness is a choreography written in laws of physics older than any myth. The aurora is the planet itself glowing, responding to the sun like a musical instrument touched by distant hands. Still standing beneath it, science feels like only part of the truth. Even knowing the physics, how electrons rush down magnetic field lines, how atoms are excited, how the light emerges, does not quiet the feeling that something ancient is unfolding. The aurora does not simply appear, it arrives. It enters the world the way a story begins, slowly, irresistibly, with a sense of quiet inevitability. Above the frozen fields, the colors grow brighter. The green arcs pull themselves higher into the sky until they seem to fold overhead like great luminous wings. Occasionally they flicker fast, sharp tremors of brightness, like thoughts sparking through some enormous mind. Then, as if shifting its weight, the entire curtain ripples. There is no sound, no crackle, no wind, only the movement of light in a silence so deep it feels physical. It is this silence that once convinced people they were witnessing something alive. It is this silence, that stillness, that makes even the most modern observer feel the pull of awe that ancient watchers knew so well. For in the quiet, the lights seem to speak, but not with noise, with presence. The snow beneath the aurora glows faintly, catching the soft emerald hue. River ice gleams pale green at its edges. The pine trees, tall and unmoving, gather the light along their branches. Even the shadows shift gently as though turning to see the sky for themselves, and as you watch the lights change again. A new wave rises, sweeping across the sky like a slow rolling tide. A whisper of red appears above the green, faint but unmistakable, a sign of oxygen glowing far beyond where air becomes almost nothing. Beneath it, thin threads of purple touch the edges of the curtain woven by nitrogen molecules struck by speeding electrons. All of it together feels like a conversation. Sunlight transformed Earth, responding the sky caught between them in a silent dialogue. For centuries, humans looked up at these same colors and wondered what force could paint the night. Now science has traced every thread of the story from the solar wind to the human retina. And yet something remains unchanged, the feeling that the aurora is both explanation and mystery, both physics and poetry. Tonight, as the lights drift and twist across the far northern sky, you join a lineage that stretches back through every ancestor who ever paused in the cold and looked upward. The aurora does not need to be believed in. It does not require interpretation. It simply is. A meeting of star and planet, a reminder of energy moving through space and touching our world with quiet grace. So breathe, let your eyes grow heavy, and let the first chapter of this cosmic story unfold around you like a slow, glowing dream. The aurora may appear as a vast, sweeping river of light, but its origin is almost impossibly small. What you see stretching across the sky in arcs of green and violet begins with particles too tiny to name, without magnification. Electrons and ions, fragments of the sun's restless breath drifting through space until the Earth's magnetic field draws them in. Imagine these particles as stardust, not in metaphor but in truth, born in the fusion furnace of the sun, carried outward on the solar wind and travelling millions of kilometres before meeting the upper atmosphere. They arrive not as a flood but as individuals, each one a traveller on an almost unimaginable journey. And the aurora begins with the moment they touch the air. High above the clouds, where the atmosphere thins into near vacuum atoms of oxygen and nitrogen, float in cold, quiet darkness. They drift without hurry, so sparse that a single breath of air here would seem almost empty. Nothing moves quickly in this rarefied world. The sun has set far below, the blue daytime sky has collapsed into deep star-laden night, and the atoms wait. Then something arrives. Electrons from the sun plunge into this dark layer, guided along magnetic field lines that curve around Earth like invisible rivers. They travel with astonishing speed, so fast that if one were to pass through a room, billions of collisions would unfold before a single blink finished. Yet when they reach the upper atmosphere, the story slows down. The charged particles meet the atoms suspended in the cold, and each encounter becomes a moment of transformation. Think of two dancers meeting in a silent hall. The electron strikes an oxygen atom, passing some of its energy into the atom structure. For a brief moment, the atom changes. Electrons inside it jump to higher orbits, like stepping onto an upper stair where they do not normally belong. The atom enters what physicists call an excited state. It is unstable, temporary, a kind of held breath in the world of quantum mechanics. And then, as all things do, it returns to rest. But before it settles, it must release the energy it was given. And that release comes as light. Green if the oxygen is 100 kilometers above Earth. Red if the oxygen sits far higher in the thin edge of space. Purple or blue if nitrogen molecules are struck lower down where the air thickens. Every color you see in the aurora is the quiet exhale of an atom returning to balance. This is the heart of the aurora, electrons from the sun knocking on the door of Earth's atmosphere, and atoms responding with a glow. A meeting so small it happens billions of times every second, and yet so gentle it creates a light that looks soft enough to touch. It is the physics of quantum transitions, electrons leaping, falling and emitting photons translated into something the human eye can follow across the sky. On the ground, the display looks continuous, a flowing, sweeping movement as if the sky itself is lifting in slow tides. But in reality, each shimmer is made of countless individual flashes, each lasting less than 1,000th of a second. The appearance of stability is an illusion created by sheer abundance. The aurora is not one glow, but millions of tiny flickers layered into ribbons, each born from the same microscopic process repeating endlessly across the dark. A vast celestial drama constructed from sparks too small to see. If you could freeze time for just a moment, if you could stop the lights in mid-motion, you would find the truth hidden inside the glow. The arcs are not smooth surfaces, but tapestries of individual photons, each representing a single atom releasing borrowed energy. The curtain-like folds are shaped not by wind, but by electric fields, guiding streams of electrons into pathways drawn by magnetism. Even the shimmering edges, the delicate fraying at the tips of each ribbon, are simply places where the density of collisions changes where more atoms glow at once. The beauty is not in the size, but in the scale of repetition. In the cosmic patience of the universe performing the same tiny act of energy exchange millions of times, to paint a single arc of green light. And yet, the process is not only mechanical. There is something almost intimate about these collisions. They happen where Earth meets the Sun in the thin border that belongs fully to neither. It is a threshold, one of the few places in nature where the energy of a star directly touches the breath of a planet. Where solar wind enters the magnetic shield, slips into the atmosphere, and sets it softly glowing like embers stirred in a deep blue night. The aurora is the visible record of this meeting, a reminder that Earth is not isolated but continually connected to its star through invisible currents of charged particles. If you stand beneath the lights, this connection becomes palpable. You can almost sense the unseen movement above you, the way electrons spiral along magnetic lines, the way atoms take in energy and release it with a faint whisper of colour. The sky looks alive because something truly is happening, something dynamic, constant, and impossibly fast. These micro-collisions, these tiny quantum sparks, create waves of brightness that move like water or wind. But their motion is not governed by weather. It is governed by magnetism, a phenomenon that does not rustle leaves or stir snow, yet shapes the entire geometry of the display. The arcs stretch east to west because Earth's magnetic field lines run that way. The curtains appear to fold and ripple because the incoming electrons follow pathways that shift and breathe as the magnetosphere responds to space weather. Every movement is a signature of invisible forces flowing overhead. In that sense, the aurora is not just light, it is a map of interactions that normally unfold hidden in the silence of space. A translation of physics that would otherwise remain abstract. A language of colour that reveals a relationship older than life itself. For billions of years, the sun has sent its charged particles outward, and for billions of years, Earth has bent those particles around itself, shaping the glow into a kind of luminous handwriting across the poles. Long before humans saw it, before mammoths crossed frozen tundra, or glaciers carved valleys into stone, the aurora shimmered in the sky as stardust touched ancient air. It is one of the oldest conversations in the solar system. Tonight, as you watch the faint beginning of a new wave rising above the northern horizon, you witness the latest exchange in this ongoing dialogue. A star breathes, a planet answers, and the sky writes their meeting in colour. The mechanism is simple, the effect is immeasurable. From the smallest spark, the highest beauty. When the aurora unfurls across the sky, it does not arrive as a single colour. Instead, it appears as a grand layered gallery of hues, each one whispering the identity of the atoms that created it. The sky becomes a painter, but atoms are the artists, each shade a unique signature of their excited states, each glow a message written in the language of energy and light. To understand the aurora's palette is to understand how oxygen and nitrogen, the two most familiar gases around us, become luminous under the touch of the solar wind. Out of all the colours, the aurora displays green is by far the most common. The bright, soft, almost ethereal glow that seems to flow like liquid jade across the sky belongs to oxygen atoms about 100 to 150 kilometers above the Earth. At this height, the air is thin, barely a breath compared to the surface, but still thick enough for collisions to be frequent. Electrons from the sun strike these oxygen atoms and lift them into an excited state. When they return to equilibrium, they release a photon with a wavelength near 557.7 nanometers, a pure familiar green. This green is the heartbeat of the aurora, the colour that wraps the sky in moving curtains and drifting rivers. It shines long enough for human eyes to see clearly. It is forgiving, stable, strong. Almost every classic photograph of northern lights features this green turning the snow below into a pale sea of emerald shadows. But oxygen has another voice, one much rarer, much more delicate and far more mysterious. High above the green band, at altitudes of 200 to 400 kilometers, oxygen atoms glow again, but this time in deep, haunting red. This red does not dance quickly. It is slower, softer, appearing like a faint blush across the upper sky. Sometimes it forms towering red pillars that rise above the main auroral arc like silent watchmen. Other times it spreads in a wide haze that feels more like a memory of light than light itself. The reason for its subtlety is simple physics at these great heights. The air is so thin that the excited oxygen atoms have time to release their energy as red light without being bumped or interrupted by collisions. Lower down, where the atmosphere is thicker, collisions happen too quickly before the red emission can occur. The energy is stolen away, turned into heat rather than light. This means the red aurora is not just a colour, it is a sign of altitude, an indicator of how quiet and spacious the upper atmosphere is. It is the breath of oxygen released only where the sky is nearly empty. Below all this, where the aurora sometimes dips closer to Earth, nitrogen adds its own colours to the story. Nitrogen molecules N2 rather than single atoms produce the blues and purples that flash along the edges of the aurora, like brush strokes of cold fire. When electrons from the solar wind strike nitrogen, the molecules vibrate and twist, then release energy in a different pattern than oxygen. Their photons come out shorter, sharper, closer to the violet end of the spectrum. These purples often appear in the lower fringe of the aurora closest to the horizon. They flicker quickly in narrow bright arcs. Because human eyes struggle with low-light blues, these hues may look white or slightly lavender to a person standing outside. But cameras, especially long-exposure ones, capture their true richness, revealing glowing lines of sapphire, indigo and violet. This is one of the aurora's quiet secrets. The human eye with all its wonder is also limited. At night, our vision shifts into scotopic mode where rod cells dominate. Rods excel at detecting faint differences in brightness, but they struggle with colour, especially in the blue end of the spectrum. That means much of the true auroral palette remains invisible to us unless the lights are unusually strong. In essence, we see only part of the gallery. The sky is more vibrant than our eyes can perceive. Imagine the aurora not as a single glowing sheet, but as a vast multi-layered museum suspended above Earth. Each altitude hosts its own exhibition. Each gas tells its own story in colour. The layered gallery of the night. At the highest level, around 300 to 400 kilometers, the air is so thin it barely exists. Here, red oxygen glows slowly, delicate, faint and expansive. In the middle layer, from 100 to 150 kilometers, oxygen creates the bright green curtain, the most iconic and most radiant part of the aurora. In the lower layer, around 80 to 100 kilometers, nitrogen molecules flare blue and violet along the edges, adding detail and texture to the composition. The aurora is not a blend of these colors, but a vertical arrangement, a natural sculpture stretching from near space down toward the stratosphere. Each hue is tied to altitude, air pressure, the energy of incoming particles, and the quantum structure of the molecules themselves. This vertical sequence, red above green in the middle, blue-violet below, makes the aurora not just a sky phenomenon, but a living layered structure, a glowing anatomy of the atmosphere. If you watch closely, you may see how the layers interact, how green curtains sometimes fold over hints of purple, how red caps form atop the arches, how certain parts brighten or fade depending on the flow of particles entering Earth's magnetic field. This interplay is the sky's choreography shaped by physics unfolding far beyond our senses. The green dances in broad fluid strokes, the red hovers with quiet, regal calm, the blue flashes with quick electric edges. Together they create a harmony that feels both scientific and deeply emotional, like listening to different instruments in the same cosmic orchestra. And yet behind every colour is a simple truth, an atom returning to its normal state after being lifted by the energy of a particle from the sun. The glow lasts only as long as the energy exchange persists. The moment the solar wind slows or shifts direction, the lights begin to dim, the gallery closes, the colours fade, and the night returns to stillness. But while it lasts, the aurora paints the air with colours that reveal the identity of the atoms themselves. Oxygen signs its name in green and red. Nitrogen signs in blue and violet. The sky becomes a vast canvas where the smallest structures in nature leave their marks in strokes large enough for entire continents to see. Tonight, as the lights rise again, green sweeping across the centre of the sky, red faintly brushing the heights, purple flickering at the edges, you're watching chemistry expressed as art. A gallery arranged not by human hands but by altitude pressure and the quantum steps of excited electrons. The sky glows in the colours of its elements, each shine a signature, and the world beneath it falls into a deeper, more contemplative quiet. In the heart of the aurora, suspended between the dark quiet of the upper atmosphere and the restless layers below, lies the Green River. It is here, around 100 kilometers above the Earth, that the aurora becomes most alive. The colors tighten, intensify, and gather into long, sweeping arcs that drift like illuminated banners in the night. These green curtains are the most familiar, the most iconic, the most deeply etched into the imagination of anyone who has ever watched the Northern Lights. To understand why this color dominates the sky, you must imagine a place so high that the air is barely there, yet still dense enough to shape the behavior of the particles streaming in from space. Here, oxygen atoms wait in a cold, quiet layer where collisions happen often enough to spark light, but not so often that the glow is interrupted. It is the perfect balance, thin enough for purity, thick enough for intensity. When electrons from the sun plunge down Earth's magnetic field lines and meet these oxygen atoms, they pass on a burst of energy. The oxygen becomes excited, its electrons jumping to higher orbits, holding that unfamiliar energy as if unsure what to do with it. And then microseconds later it relaxes. It returns to its natural state. But before it settles, it breathes out a photon. That photon is green, a wavelength of 557.7 nanometers, a color so distinctive that physicists can identify it instantly, a signature so consistent that it paints the bulk of the auroral sky in the same luminous shade across centuries. This green is not simply a color in the air, it is the language of oxygen spoken softly, but on a scale vast enough to cover mountains and oceans. And yet the dominance of green is not only physics, it is also human physiology. Our eyes in darkness shift their mode of operation. During the day, cone cells handle color and clarity, but at night the rods awaken the sensors that thrive in low light. Rod cells are far more sensitive to green wavelengths than to red or blue, making us naturally predisposed to see green best when the world grows dim. It is no coincidence that the aurora glows brightest in the color our night-adapted eyes can perceive most clearly. The Green River is not only nature's design but our sensory inheritance. The color meets us halfway. Even when the aurora contains deep reds or electric blues, our eyes may miss those entirely unless the display grows exceptionally strong. But the green, steady, natural, biologically favored reaches us with ease. It is the aurora's way of making itself known. When ancient people looked up and saw this flowing light, they did not speak of atoms or excited oxygen. They saw the world glowing in a color that resonated deeply with the rhythms of life on Earth. Across cultures, green has long been the color of growth renewal, the return of spring after a long winter, the presence of living things in a landscape shaped by frost and rock. Imagine the Inuit hunter on a frozen bay, watching the green arcs sweep across the sky like waves. To him, the lights might seem like spirits guiding migrations or marking the presence of ancestors. Imagine a Norse traveller gazing upward during a long winter night, the green curtains twisting like the banners of unseen riders. To him, they might resemble the armour of Valkyries moving between worlds. Or imagine a Sami reindeer herder standing beneath the shifting glow, feeling the air tremble with an energy he cannot name. To him, the lights might be the breath of celestial beings too sacred to call lightly. Green became a message interpreted through the lenses of survival weather and spirituality. Some cultures believed the green aurora was a path, a bridge between realms. Others saw it as a warning, a sign that the sky was alive watching. In some places, children were told not to whistle under the aurora, for fear that the lights might descend and take them away. In others, couples viewed the green sky as a blessing, believing that its glow brought fertility and luck. Across the Arctic, the green curtains became woven into mythology, as deeply as rivers, mountains, or stars. The reason may be simple: the green aurora is the most constant companion of northern nights. It is the color that appears most often, most vividly, most strongly. It becomes the landscape of the sky in winter a familiar presence in lands where darkness lasts for months. If you stand under these green rivers, you begin to understand why. The light seems to move with intention. It rolls forward, then retreats, then gathers again like fabric caught in a wind that leaves no trace on the ground. Sometimes it forms long arcs that stretch from horizon to horizon. Sometimes it breaks into narrower ribbons, each one rippling as though stirred by an invisible current. The brightest displays form towering walls of light that sweep overhead so close they feel almost tactile, like they could brush the tops of the pines. If you listen not with your ears but with attention, you might imagine a soft hum in the air, though the aurora itself makes no sound. Yet the mind fills in what the eyes cannot fully understand. The movement feels alive, electric, without noise, present without weight. For many people who witness the green aurora for the first time, there is a strange sensory impression. It feels cold and warm at the same time. Cold in its colour, in its shimmering clarity. Warm in its motion, in the soft way it drapes the sky like silk, illuminated from within. Some describe it as the sky breathing. Others say it feels like watching the sea turn upside down. A few say it feels like standing inside a dream. This sensory paradox, fluid yet still cold, yet warm, silent yet seemingly full of voice, is part of why the green aurora lingers in the memory long after the lights fade. It is not simply a visual experience. It is an encounter with a phenomenon that seems to occupy a space between the physical and the emotional. Scientists can tell you that the green aurora forms in the middle atmosphere where oxygen atoms meet solar electrons. Physicists can break down the exact wavelengths and excitation states. But none of that diminishes the way the Green River feels when it appears overhead. You look up and the sky responds. You stand still and the aurora moves. You breathe out and it seems to breathe back slowly, gently in rhythms older than words. The Green River of the middle sky is above all an invitation, an offering from the earth itself written in a colour that humans are uniquely able to see even in the deepest night. A soft reminder that our world is not quiet even when the landscape sleeps beneath snow. Tonight, as the green ribbons drift overhead, the atmosphere feels close, intimate, as if the sky has lowered itself to meet you. And in that luminous stillness, the night becomes something more than dark. It becomes alive. Far above the bright green river of the middle sky, beyond the height where nitrogen flickers, and below the cold vacuum where satellites glide silently through darkness, there exists a realm almost untouched by air. It is here between 200 and 400 kilometers above Earth that the atmosphere thins into a fragile whisper, a region so empty that a single breath of air would scatter into nothing. And in this quiet, nearly airless world, a different kind of aurora is born, the red aurora. Unlike the quick bright greens below it, the red glow forms slowly like a lantern being lit in slow motion. It spreads across the upper sky as a faint crimson haze, sometimes so subtle you might question whether it is truly there. Other times it rises as tall, straight pillars that loom above the green curtains, like ghostly sentinels, silent, unmoving, luminous. This is the aurora at the edge of space. Its colour is not a sign of fire or heat. It is the signature of oxygen atoms glowing in a place where the rules of movement are different, quieter, slower. The process that creates the red aurora begins the same way as the green solar electrons collide with oxygen atoms. But up here in the thin reaches above 200 kilometers, something important changes. The atoms are so far apart that they almost never bump into one another. An excited oxygen atom can hold its extra energy for more than a full second before it releases it as a photon. In the dense air below, this would be impossible. The atom would be jostled, its energy stolen by collisions before it could glow. But here at the boundary between atmosphere and vacuum, time stretches. The oxygen has room to breathe, and when it releases its energy, the light that comes out is deep red, an emission at 630.0 nanometers, soft and haunting, like a distant ember floating in the night. It is the longest, slowest exhale in the aurora's layered gallery. Because the air is so thin at these heights, the red glow spreads wide, painting huge regions of the sky with faint crimson. It does not ripple or rush the way green does. It drifts, it lingers, it behaves with a kind of cosmic patience, as though the lights are moving through syrup instead of air. If you've ever watched the red aurora on a clear night, you may notice this difference immediately. While the green arcs below twist and curl like living silk, the red above sits steady, stately, almost solemn. It feels like a background, a canopy of colour holding the more active aurora beneath it. But this stillness is an illusion of altitude, the quiet signature of a place where air barely exists. Standing on Earth looking up at this quiet red veil, you're seeing a colour that belongs to the boundary of our world. Not the surface, not the middle atmosphere, but the place where Earth releases its grip and space begins. And because the red glow forms so high, it often appears long before the green aurora becomes visible. Sometimes hours before the main show begins, a faint reddish tint appears in the northern sky, like distant fire reflected on low clouds. For people without scientific grounding, this early glow was confusing, unsettling even. Early explorers wrote of blood spreading across the heavens. Arctic sailors spoke of the red mouth of the sky. Medieval observers described the glow as cities burning beyond the horizon. In East Asia, chronicles sometimes recorded it as an omen of war or plague, and in parts of medieval Europe, priests treated it as a sign of divine anger. None of them could have known they were simply seeing oxygen atoms glowing peacefully in the upper atmosphere, signaling the beginning of a geomagnetic storm. Even in the 1800s, during strong solar events, newspapers described crimson auroras as massive wildfires. Dispatch riders were sent to investigate forests that were not burning. The red aurora once startled entire towns into action, prompting fire brigades to chase flames that existed only in the sky. It is easy to understand why. Red is a powerful color to the human mind. It speaks of heat, danger, blood survival. When the sky turns red at night, high above, silent and slow, it taps into instincts older than civilization. The red aurora feels like something enormous is happening just beyond the horizon. But the truth is gentler. The red veil is one of the quietest lights in nature. It is the glow of atoms too sparse to hurry. It is the color of slow motion suspended in air that is barely air at all. Even today, with satellites floating through that very region, the red aurora retains its mysterious quality. From Earth, it appears distant, unreachable. From orbit, astronauts see it from above, spreading across entire continents, soft pinkish sheets stretching thousands of kilometers, glowing along the edge of Earth like a cosmic blush. To them, it looks like the planet has been dipped into rose-colored light. From that vantage, the layered structure becomes clear green lower down, shifting and alive. Red above, floating, serene like a cloak draped over the world. The red aurora, though faint, is vast. During strong geomagnetic storms, it can stretch from pole to pole, painting the night sky, across countries that never expect to see the northern lights. When this happens, people in lower latitudes see something rare and unsettling, a crimson haze covering the sky where stars should be. These are the blood-red auroras of historical records, the events that left fearful impressions on entire generations. And yet nothing dangerous is happening in that moment, only the slow dance of oxygen at the edge of space glowing in a light that takes its time. If green auroras feel like wind and water alive responsive, then the red aurora feels like stillness itself. It is the quiet watcher, the silent layer above the storm. Once you recognize it, its presence becomes comforting, a sign that the Earth is in conversation with its star. If you stand beneath a red aurora long enough, you may begin to sense that stillness. The cold air around you feels heavy, but the sky above looks unbearably light, as though gravity has drifted away. The stars blink behind the red haze, softened. The world seems farther away. The silence grows deeper. It feels like standing at the doorway between Earth and space. Up there in the thin frontier between our atmosphere and the infinite dark oxygen atoms, glow in a color that is both gentle and profound. They glow because of a journey that began in the core of the sun, traveled across space, and ended in the quietest heights of our planet's atmosphere. Tonight, the red veil waits above the green river, suspended in the stillness of the upper sky. Patient, ancient, and calm, a light at the edge of the world. Beneath the green river, and below the faint red veil at the edge of space, lies another sharper layer of auroral color, fleeting fast and colder in appearance than anything else the sky can offer. It is the blue and purple glow of nitrogen, a color that appears not in slow curtains, but in flashes, sparks, and narrow waves that race across the lower reaches of the aurora. If the green aurora is a flowing river, and the red aurora is a drifting mist, the blue and violet lights of nitrogen are breath-quick, crisp, and alive like a sudden exhale on a winter night. Most of the air we breathe is nitrogen. It surrounds us continuously, yet remains invisible under normal conditions. But when the charged particles from the sun plunge deep enough down to about 80 to 100 kilometers, Nitrogen molecules begin to participate in the cosmic conversation. Unlike oxygen, which glows with smooth, lingering colors, nitrogen responds to energy with quick transitions and fast electron rearrangements. It lights up briefly brilliantly, then vanishes, each flash lasting only microseconds. These flashes blend together into shimmering edges, bright borders and fine filaments that lace the bottom of the aurora. To understand why nitrogen behaves this way, imagine a molecule as a small vibrating structure. Nitrogen molecules N2 are tightly bound pairs of atoms. When a solar electron strikes them, the molecules can become ionized, losing an electron, or excited into higher electronic and vibrational states. Each state has its own way of releasing energy, ionized nitrogen. N2+ emits a brilliant cold blue. Neutral excited nitrogen N2 glows violet or purple. These colors are born in narrow, quick bursts because nitrogen returns to stability far faster than oxygen does. Where oxygen at high altitudes takes a full second to release red light, nitrogen completes its transitions thousands of times faster. The result is a color that flickers rather than flows, like frost catching sudden light. If you watch closely during a strong aurora, you may notice this phenomenon at the base of the green curtain. The edges glow with a crisp purple rim, especially when the aurora is active and moving quickly. Bright blue lines sometimes flash like electricity running along the lower boundary, darting like sparks before fading again. To the human eye, these colors often appear faint because our night vision struggles with blue wavelengths. But with enough brightness or through a camera, the true shades emerge: deep violet, electric blue, icy lavender at the edges. They look like the coldest colors in nature, colors you might associate with glacial cracks, moonlit snow, or the strange blue that hides at the center of a shadow on a winter morning. In fact, the entire experience of seeing nitrogen auroras feels like standing in deep cold. The visual associations are immediate. The purple fringe has the sharpness of frost, forming on glass. The quick blue flashes resemble the sparkle of ice as it catches the last trace of twilight. The motion of the wave fronts is like wind whisking powder snow across a frozen lake. Everything about nitrogen auroras feels crisp, sharp, fleeting. And because these auroras form lower in the atmosphere, where air is thicker, denser and more dynamic, their movement is shaped by fast-changing currents and denser particle flows. The light doesn't drift or swell, it streaks, it flares. It appears and disappears in narrow folds traveling along the bottom of the auroral curtain, like a line of cold fire. Scientists call these sudden bursts fast-moving wavefronts, thin bands of charged particle precipitation that sweep across the sky in seconds. When nitrogen glows inside these wavefronts, the result is a brief flash of blue or purple, a signature of rapid energy transfers. Imagine a single electron plunging downward through Earth's magnetic field. It carries enormous kinetic energy accumulated across millions of kilometers of travel from the sun. When it finally collides with a nitrogen molecule, the impact is like a tap on a crystal, momentary intense, immediately resolved. The nitrogen molecule jumps into an excited state. It quivers for a fraction of a heartbeat. It returns to equilibrium, releasing a photon, and then it rests again. The entire process is so quick that the light barely has time to gather into anything resembling a shape. Only when trillions of these flashes occur together along a narrow band or moving front do we perceive a line of color. A blue ripple, a violet edge, a cold shimmer at the bottom of the sky. Early observers rarely mentioned blue and purple auroras, not because the colors weren't there, but because our eyes are least sensitive to them. Many people simply saw pale white fringes or faint silvery glows. It wasn't until photography began capturing long exposures that the presence of nitrogen colors became widely recognized. Suddenly the sky revealed extra dimensions, hidden colors layered beneath the green. And once seen, it's impossible to forget. For those who stand beneath a nitrogen-rich aurora, the sensory associations are strong. The lights feel sharper, colder, more staccato. The green river flows like silk. The red veil drifts like warm breath, but the purple fringe crackles. It has an edge. It looks like the atmosphere exhaling frost. In some cultures, this cold light carried meanings all its own. Certain Arctic groups spoke of the lower purple edge as the border of the sky, the line separating the world of the living from the world of spirits. Some said the violet flashes were the cracking of ice in the heavens, the sky freezing and thawing in luminous cycles. Others believed the purple glow marked places where stars were born or where spirits traveled between realms. Even today, the blue and purple auroras remain among the least understood by casual observers simply because they require stronger storms or very dark skies to appear vividly. But when they do, they transform the aurora into something layered and complex, like the colours of fire seen through ice. If the aurora were music, green would be the low, steady tone, the main melody. Red would be the slow note held above it, soft and distant. And nitrogen's blue and purple flashes would be the quick, bright accents, the crystalline chiming that adds sharpness to the harmony. When you see them, you are witnessing one of the most dynamic parts of the auroral dance, a conversation between the sun's electrons and Earth's nitrogen played out in flashes too fast to follow individually, but together forming a luminous breath at the bottom of the night. Tonight, as the green curtains ripple and the red haze lingers above them, watch the lower edge. You may catch a brief purple spark, a thin blue fringe, a momentary ice-like shimmer. It will come and go quickly, just a breath. But in that breath, the sky reveals another of its secrets. The coldest colours painted by the molecule that fills our world. Long before the aurora lights the night on Earth, long before oxygen glows green and nitrogen flashes violet, the story of the northern lights begins somewhere far away in the heart of the sun. Not on its surface, where sunspots swirl and bright arcs leap into space, but deep inside in the region where light itself is born. Imagine a world of unimaginable pressure, a place where hydrogen atoms are pressed so tightly together they fuse into helium, a place hotter than any flame we know, 15 million degrees dense enough to resist the very concept of empty space. This core is the engine of the sun. Every second it releases energy equivalent to the detonation of billions of nuclear bombs, yet it does so in silence, in perfect rhythm, balanced by gravity and heat. Here, photons begin a journey that will take thousands of years to reach the surface, bouncing from atom to atom in a slow march outward. But alongside the birth of light, something else stirs here: magnetic fields. Magnetic. Deep within the sun's churning plasma, electric currents twist and fold upon themselves. The sun is not solid. It is a whirlpool of charged gas constantly rotating, dragging magnetic fields with it in loops and spirals. These fields rise slowly through the layers of the sun, carrying the complexity of the interior up toward the surface like submerged ropes tugged upward by unseen hands. When they reach the visible surface, the photosphere, they burst through in pairs, forming sunspots, dark, cooler regions where magnetic fields twist tightly like strands of thread wound too many times. But the real storms begin above the surface. The sun's magnetic field is not a gentle, ordered system. It is a tangled forest of loops, arches, and lines stretching thousands of kilometers into space. These loops are constantly being pulled, stretched, pinched, and knotted by the sun's own rotation and convection. The result is tension magnetic knots, accumulating energy with quiet intensity. When these knots become too twisted to hold, they snap. The release is instantaneous. A solar flare erupts, an explosion of radiation across the electromagnetic spectrum. Ultraviolet, X-rays, high-energy photons that burst outward at the speed of light. A flare is not flame. It is a rearrangement of magnetic energy so powerful it heats plasma to tens of millions of degrees in a fraction of a second. But the most dramatic events happen when whole magnetic loops break open. These ruptures create coronal mass ejections, immense clouds of charged particles and plasma hurled into space. CMEs carry billions of tons of solar material traveling at speeds up to 2,000 kilometers per second, swelling into enormous bubbles as they expand across the solar system. If you could stand on the sun, impossible of course, but imagine it, you would see these eruptions not as explosions, but as the sun breathing out solar storms, gigantic luminous exhalations of energy and particles launched into the dark. And yet these storms are not random. They follow rhythms as old as the sun itself. Every 11 years, the sun goes through a cycle of magnetic activity. Its magnetic field flips north, becomes south, south becomes north. During the peak of this cycle, sunspots multiply, flares intensify, and CMEs become frequent. During the quiet years, the sun's surface smooths the loops, unwind, and the magnetic forest becomes calm again. But whether the cycle is high or low, whether the day is quiet or restless, the sun never truly rests. Beneath every calm morning on Earth lies a star filled with movement, rising and falling in tides of plasma and magnetism. And though it is 150 million kilometers away, the sun's storms are deeply linked to our world. Most of the particles expelled by flares and CMEs never reach Earth. They drift through space, spreading thinly across the solar system. But some eruptions send a stream, what we call the solar wind, directly toward our planet. These particles travel for days, crossing vast distances in silence. They do not give off light. They do not glow in vacuum. They simply move, carried by electric and magnetic forces, following the invisible pathways traced by the sun. If you could see that journey, it would look like a faint shimmering chain stretching from the star to Earth. Not a physical chain, but a connection of charged particles, moving fields and flowing energy, a continuous thread of influence tying our world to the star that sustains it. When this solar wind reaches Earth, it encounters the magnetic field that surrounds our planet. Earth's magnetosphere is our shield, deflecting most of the incoming particles, guiding others toward the poles. The moment these particles become trapped along the magnetic lines, their journey becomes inevitable. They will spiral downward toward the atmosphere. Everything that happens next, the green rivers, the red veil, the violet flashes, begins with this moment of contact between star and planet. It is remarkable, really. A storm that began in a region hotter and denser than anything on Earth finds its conclusion in a whisper of light drifting across a frozen sky. A magnetic knot formed deep inside a star can become a faint shimmer, seen by someone standing silently on a snowy ridge, breath fogging in the cold air. The chain of events is immense in scale, yet the result is gentle, almost tender. It is a reminder that the universe often translates its greatest powers into the softest signs. Early astronomers watching the sun through smoked glass or primitive telescopes noticed the black spots drifting across its surface. To them, these spots were ominous blemishes, signs of disease in the solar body. Only centuries later did we understand that they were windows into magnetic storms, markers of activity that could shape the colors of the Earth's night sky. Today we watch the sun with fleets of satellites measuring every ripple of its magnetic field. We observe flares in real time, mapping the tangled loops that leap upward. We track CMEs as they race toward Earth, predicting the auroras they might create. And yet, for all our knowledge, something about the sun's storms still feels mysterious. Perhaps because the processes remain invisible to us. Perhaps because they begin in places we will never see directly. Or perhaps simply because the sun itself is too large, too powerful, too ancient to ever seem fully knowable. But we do not need to understand every detail to feel the connection. When the sun twists its magnetic ropes, Earth feels the pull. When the sun exhales, a storm, our sky glows in response. When the sun stirs, the aurora awakens. A chain stretching across millions of kilometers, linking our world to the star at its center. Tonight, as you look up at the aurora, whether it glows green, red, or purple, you're seeing the final echo of a storm that began inside the sun long before it reached Earth. A soft, luminous end to a journey that started in fire. Long before the first hint of color appears in the night sky, Earth prepares for the storm. It does so silently, without sound or motion that the human body can feel. Yet above us, far beyond the clouds, beyond the air we breathe, an invisible guardian stirs. Earth's magnetic field is one of the planet's oldest companions. It was born billions of years ago from molten metal churning in the core, a restless ocean of liquid iron spinning slowly under unimaginable pressure. This ocean behaves like a natural dynamo. As it moves, it generates magnetic forces that rise through the mantle and burst outward into space, creating the magnetic shield we live inside every hour of every day. From space, this field looks like a vast bubble gently surrounding the planet, a shell of invisible lines stretching outward, like the ribs of an enormous lantern. Scientists call it the magnetosphere, but the name hardly captures its grace. It is not static. It breathes. It flexes. It leans toward the sun like a tree bending in the wind, then stretches behind Earth into a long tail that drags across the darkness for millions of kilometers. This shield is far larger than Earth itself. It extends so widely that the moon passes through its outer edges during parts of its orbit. Yet from the ground, we never see it. We feel nothing. The magnetic field works quietly, guiding compasses, deflecting cosmic radiation, and holding back the solar wind that blows from the sun in a constant, steady stream. But when a solar storm arrives, when a coronal mass ejection barrels through space, or when the sun breathes out a faster gust, the magnetosphere awakens. As the incoming plasma meets the magnetic field, the front of the magnetosphere compresses dramatically, like a shield absorbing the force of an incoming blow. The long tail behind Earth tightens, storing tension like a drawn bowstring. Within this invisible structure, energy begins to move. Field lines twist, stretch, and sometimes even snap and reconnect, releasing bursts of power that cascade down toward the planet. It is in these moments, these quiet rearrangements far above our world, that the aurora begins to take shape. Earth's magnetic poles, though often drawn neatly at the top and bottom of a globe, are not fixed points. They wander slowly over time, drifting across Arctic ice and Antarctic snow in long arcs measured over decades. Their motion is subtle enough that only scientists track it closely, but it matters deeply for the aurora. Because the aurora does not follow geographic latitude, it follows magnetic latitude. Wherever the magnetic poles move, the auroral ovals follow. These ovals are not literal circles, but shimmering rings of potential light that surround the poles. When solar particles approach Earth, the magnetosphere funnels them along its field lines toward these regions. The field lines curve inward just above the poles, creating two great gateways, where the solar wind can finally meet the atmosphere. Imagine long magnetic rails stretching from space to Earth, curved pathways that guide electrons and protons downward, spiraling them ever closer to the air. These rails form the boundaries of the auroral ovals, shaping the very places where the aurora will appear. That is why some countries see lights often while others never do. It is not simply a matter of latitude, it is a matter of magnetic geography. Inside these ovals, the magnetosphere works like a conductor directing an orchestra. Particles flow along the lines, guided into arcs, curtains and ribbons that mirror the shape of the magnetic field itself. When the field ripples, the aurora ripples. When the field bends, the light bends. When the field snaps back into place, bright surges race through the sky, like lightning running across silk. The aurora is not a random glow of colour. It is the magnetic field made visible. If we could see the magnetosphere in broad daylight, it would resemble a shimmering cocoon surrounding Earth. The front side pressed inward by the solar wind. The back side pulled into a long tail, a shadow of magnetism stretching into deep space. Within this tail, energy gathers during storms until it can no longer hold. When the tail finally releases that built-up pressure, it sends charged particles racing toward the poles in a sudden rush. This moment, known to scientists as reconnection, is one of the most powerful natural processes occurring near Earth. Though silent and invisible to us, its echo becomes the brilliant surge of the aurora that spreads across the night sky. And yet, even during these moments of tension, the magnetosphere protects us. Without it, the solar wind would erode the atmosphere itself, stripping away air molecule by molecule the way it once did to Mars. But Earth is shielded by this magnetic armor, a force field created not by technology, but by the planet's own beating heart of molten metal. There is something humbling in the thought that every compass needle ever made is responding to this ancient engine within the Earth. Long before humans learned to shape iron or understand magnetism, the field was already here. A silent guide that shaped the movement of migrating animals, directed particles from the sun, and sculpted the polar sky with color. The drifting of the poles adds yet another layer of mystery. They do not sit still, they wander. Slowly, steadily, the North Magnetic Pole has been moving across the Canadian Arctic towards Siberia at speeds that have increased in recent decades. As the poles drift, so too does the auroral oval, shifting the regions most likely to see the aurora. The changes are gradual, almost imperceptible in daily life, but they are part of the Earth's living rhythm. When a solar storm arrives, the magnetosphere tightens its shape like a drumhead pulled taut. Electric currents begin to flow along the field lines linking space to the upper atmosphere. Satellites detect sudden changes in magnetic pressure. Ground-based sensors feel tiny fluctuations, barely measurable ripples, that signal the beginning of a geomagnetic storm. But down on the surface, none of this is felt directly. The grass does not sway, the wind does not rise, the air does not tremble. Everything unfolds in silent layers far above invisible, except for the moment when the sky answers in color. It is astonishing that something so powerful can be so quiet. Energy from the sun traveling across the vast emptiness of space meets Earth's magnetic shield with the force of a cosmic tide, and yet the only sign we see is a whisper of light drifting across the polar night. A soft green curtain, a faint red veil, a flash of violet at the edge of vision, This is the gift of the magnetosphere. It transforms violence into beauty. Every aurora you have ever seen began with Earth's magnetic field, awakening, shifting, guiding, and shaping energy that originated in the heart of a star. And as the lights drift across the frozen horizon, they reveal the invisible architecture that surrounds us, the great magnetic breath of the planet glowing softly against the dark. Most people know the aurora by a single name, the Northern Lights. But the aurora is not truly a northern phenomenon, it is a global one. For every shimmer that brightens the skies over Alaska or Scandinavia, a matching glow blossoms in the far south over Antarctica. Two lights separated by an entire planet, yet born from the same pulse of energy. They rise together, fade together, and dance in quiet harmony across the polar night. To understand the aurora is to recognize this symmetry, to see Earth not as a sphere with one crown of fire, but with two. Satellite images reveal this truth beautifully. From orbit, the planet looks like a darkened lantern lit from both ends. At the top, a circular ring of pale green wraps around the Arctic Ocean. At the bottom, a twin ring glows above the Antarctic ice. Together they pulse with the rhythm of Earth's magnetic breath. It is here that the phrase planetary heartbeat feels real. The auroras brighten and dim in cycles sometimes slow and smooth, sometimes sudden and intense, mirroring the flow of energy through the magnetosphere. When solar storms arrive, both rings flare outward, expanding like lungs inhaling light. When the storm passes, they contract again, exhaling into darkness. Two hemispheres, one rhythm, one electrical system tying Earth to the sun. To a person standing on a snowy ridge in the north, this connection feels distant. The aurora appears as a local wonder, a private gift written across their own sky. But high above, the magnetosphere tells a different story. Every burst of light in the Arctic has a corresponding burst in the Antarctic, sparked by the exact same stream of charged particles spiraling down magnetic field lines that link the two poles like an invisible thread. These magnetic lines do not stop at the equator. They stretch from one hemisphere to the other, looping through the field like strands of a giant harp. When energy flows into the system, it travels along these lines in both directions. One end of the line dives into the north, the other dives into the south. And wherever the line enters the atmosphere, the aurora appears. This is why scientists speak not of auroras, but of conjugate auroras, paired lights that answer each other across the globe. From the ground, the symmetry is impossible to witness directly, but from space it is unmistakable. Astronauts aboard the International Space Station sometimes fly over the northern ring, watching it ripple and brighten beneath them. Moments later, they orbit across the bottom of the world, where a similar arc stretches over the frozen wasteland of Antarctica. In time-lapse footage, the two ovals appear to flicker in near unison, linked by magnetic currents that pulse through the magnetosphere like blood through veins. It's astonishing to think that while someone in Norway might be watching emerald curtains dance above fjords, researchers at an Antarctic station half a world away could be witnessing the same glow forming above ice cliffs and katabatic winds. Two viewers standing on opposite ends of the Earth joined by a single unseen phenomenon. This synchronicity is not perfect, and that imperfection makes the aurora even more fascinating. Earth's magnetic field is strong but not fully symmetrical. The poles are not aligned with the geographic axis, and the field lines have slight tilts and warps. The solar wind itself adds further complications. Its direction speed, an embedded magnetic field, can distort Earth's magnetosphere unevenly. As a result, the northern and southern auroras sometimes differ in shape or brightness. The north might flare hotter, the south might stretch wider. One ring may ripple faster than its twin, but even in their differences the connection holds. They are not mirror images. They are siblings, related, bonded, yet individually shaped by the moment-to-moment physics of the solar wind. When scientists map the auroral ovals with satellites, they see them pulse like two distant fires responding to the same invisible wind. When a magnetic reconnection event erupts in Earth's magnetotail, both hemispheres brighten within seconds. When a shockwave from the sun compresses the magnetosphere, both rings thicken and intensify. Their timing is often so close that the delay is shorter than the blink of an eye. The auroras are in a sense Earth's two candles burning at opposite ends of the same wick. This global symmetry also holds deeper meaning in the language of plasma physics. The aurora's paired nature proves that Earth's magnetosphere is a single unified system. Energy entering at one point does not stay local. It flows, circulates, and intertwines through magnetic loops that span hemispheres. The aurora reveals these pathways in glowing colour, giving us a visual map of the planet's hidden architecture. In the north, people have woven myths around these lights for millennia, stories of spirits, warriors and skyborn ancestors. In the south, far fewer humans have witnessed the lights simply because so few people live beneath that remote sky. Yet the southern aurora australis, is no less magnificent. In fact, it is often more intense, strengthened by slight asymmetries in the magnetic field. From the ground, the southern glow feels like a private secret, a spectacle preserved for a world of ice and silence. From space, it is part of a pair, two lights answering the same call. Imagine the Earth suspended in the dark, wrapped in two luminous crowns, one above the Arctic, one above Antarctica, both glowing softly, breathing in slow, magnificent pulses. This is the planetary heartbeat made visible, the rhythm of solar energy entering Earth's magnetic shell. The ebb and flow of charged particles travelling along magnetic veins, the living response of a planet touched by its star. It is a reminder that even when we look up alone at night, believing the lights above us belong only to our sky, a companion glow is rising in the opposite corner of the world, another crown on the other pole of Earth, completing the symmetry of a dance as old as the planet itself. Two poles, two lights, one heart. The aurora may look soft and fluid from the ground, like silken cloth stirred by a quiet wind, but behind every fold of light lies a hidden architecture. It is not random, not chaotic. Every curve, every ripple, every sudden brightening is written by the geometry of Earth's magnetic field. The sky is not a canvas. It is a map of invisible lines, and the aurora is the glowing ink tracing them. Magnetic field lines rise from one pole, arc across space, and dip into the opposite hemisphere in long, elegant loops. They twist and bend, shaping the magnetosphere like strands of hair caught in a slow, celestial breeze. Most of the time they remain unseen, but when charged particles stream along them and collide with the atmosphere, those invisible lines become visible as curtains of light. If you could stand high above the Earth, far beyond the atmosphere, you would see the aurora form not as a flat sheet, but as immense ribbons tethered to magnetic lines that descend into the poles. Each bright arc you see from the ground is in truth a vertical plane of glowing air, aligned with the invisible direction of those lines. The aurora is not random motion, it is field geometry made luminous. The magnetic field lines act like rails, guiding electrons downward in spiraling paths. The particles dance along the field, tracing its elegant curves, the way iron filings arrange themselves around a magnet. The light we see is simply the final whisper of that journey. But the ribbons, those tall, narrow sheets of colour, become even more fascinating when the magnetosphere is disturbed. Solar storms twist and stretch the field, injecting energy that travels along the lines like currents through wires. When the pressure changes, the field vibrates, and when the field vibrates, the aurora dances. Sometimes the ribbons ripple like fabric in wind. Sometimes they snap into place like flags catching a sudden breeze. Sometimes they shimmer with tiny waves racing upward, as if the curtain is trembling. These motions are the fingerprints of plasma instabilities, subtle behaviors in the electrically charged gases flowing around Earth. The magnetosphere is a plasma environment where particles and magnetic fields are intimately tied. When energy builds up or releases in bursts, the plasma around the field lines begins to oscillate. These oscillations cascade downward, shaping the glowing curtains below. There are nights when the aurora appears calm, floating in long, smooth arcs. But even then the lines are humming with structure, and on other nights, especially during powerful magnetic storms, the aurora erupts into patterns so intricate they feel almost impossible. Braids of light twisting together, ribbons folding into spirals, bright knots forming and dissolving in seconds. These shapes are not illusions. They are the natural expressions of electromagnetic forces sculpting the sky. At the base of the auroral curtain, where nitrogen flashes blue and purple, you sometimes see thin rays, vertical shafts of light, as narrow as a pencil extending upward for hundreds of kilometers. Each ray aligns perfectly with a single magnetic field line. There are thousands of rays in a single curtain, each one marking a distinct channel through which electrons fall. From the ground, they blend together into a sheet. From above, they look like harp strings glowing in the dark. The geometry becomes more dramatic when instabilities ripple through the field. One of the most striking is the Kelvin-Helmholtz instability. the same phenomenon that creates wave patterns in clouds or ripples in river currents when two layers of fluid slide past one another at different speeds. In the magnetosphere, these instabilities occur at the boundary where the solar wind brushes against Earth's magnetic field. When this happens, enormous wave-like motions form rolling through the plasma-like ocean swells. The aurora responds, the long curtains fold into repeating wave shapes as though the sky itself is breathing in slow rhythmic motions. Another instability, the field line resonance, makes the magnetic lines vibrate like strings on a cello. When the frequency is just right, the auroral curtain pulses with vertical waves, shimmers that travel upwards so fast they seem to flicker. This is why some auroras look as if they're alive with motion rising and falling like a tide of light. And sometimes during the most active storms, the magnetic field becomes unstable enough for breakup arc's sudden chaotic bursts of motion at the onset of an auroral substorm. In these moments, the sky shifts from calm to wild. Curtains twist violently, ribbons split apart, and bright knots of oxygen and nitrogen light erupt like sparks from a hammer striking steel. It is the magnetosphere releasing pent-up energy in a rapid, breathtaking display. If all this seems too complex, think of a simpler metaphor. Earth's magnetic field is a great harp strung across space. The solar wind is the musician, and the aurora is the music made visible. Every ripple is a plucked string, every curtain is a harmonic wave, every shimmering pulse is resonance traveling along magnetic lines. The music is silent to our ears, but the sky reveals it in color. Even the graceful arcs, the classic shape of the aurora seen in countless photographs, tell a story of magnetic geometry. These arcs form where the field lines curve toward the Earth, creating a boundary between open and closed magnetic regions. When currents flow along these lines, the air glows exactly where the geometry dictates. The result is a perfect sweeping curve that stretches across the horizon, following the magnetosphere's elegant architecture. From nearby, the aurora looks delicate, fragile fluid. From above, it looks like a structured system of immense scale. From deep inside the magnetosphere, it looks like electricity flowing along the fingers of a giant hand. Magnetic fingers, shaping every movement of light. If you've watched the aurora for a long stretch of time, you may have noticed something subtle. The light rarely moves horizontally across the sky. Instead, it rises and falls, flares and dims, ripples and twists all along the direction of the magnetic field. Every motion honors the invisible lines that guide it. Even the most chaotic displays obey this rule. No matter how wild the shapes become, the aurora never breaks free of the magnetic geometry. It bends with it. It follows it. It reveals it. Nature's most visually fluid phenomenon is at its core one of the most constrained. Every flicker, a tribute to the structure of Earth's magnetic shell. Tonight, if the sky is dark and the solar wind is strong, you might see those magnetic fingers at work. A curtain may rise sharply along a narrow arc. A ripple may travel upward, racing along a line you cannot see. A ribbon may twist, revealing the torsion of field lines above. All of it shaped by forces older than life, older than continents, older than the oceans themselves. The aurora is the choreography of the magnetosphere geometry, transformed into art physics, transformed into motion in visible lines, made visible for a few luminous moments. The magnetic fingers of Earth are always there. You simply need the night, the cold, and a whisper of solar fire to see them. If you have ever stood beneath a restless aurora, you know the feeling. A curtain of light that should be silent and slow suddenly moves with the speed of a living thing. It ripples upward in an instant. It folds into braids. It sharpens into jagged teeth. All of this happens in absolute quiet. The aurora is the only lightning in the sky that never makes a sound, and yet it moves with a velocity that belongs to storms. To understand this strange illusion, this living motion written in light, you must imagine something happening far above the glowing air, the sudden precipitation of electrons falling toward Earth at tremendous speeds. These electrons, guided along magnetic field lines, plunge into the upper atmosphere like rain that moves not through clouds but through electric pathways. The electrons travel fast, not just fast compared to wind or weather, but fast compared to the human sense of motion. Though not travelling at the literal speed of light, they move so quickly, thousands of kilometers per second, that their descent translates into instant flashes of colour. When these electrons strike oxygen or nitrogen, they excite the atoms, prompting them to release photons. A beam of electrons hitting a narrow region becomes a streak of light. A sheet of electrons falling along a broader zone becomes a curtain. And when the stream intensifies suddenly, the aurora brightens with the abruptness of a camera flash. The result is a sky that appears to change shape faster than any natural phenomenon on Earth's surface. A sky that seems alive. One of the most mesmerizing motions in the aurora is the sudden upward sweep, a wave of brightness racing toward the zenith. This movement is not the light itself traveling upward. It is a wavefront of electron precipitation sweeping along a magnetic field line. When the field vibrates or reconnects in the magnetosphere, the downward flow of electrons shifts location, giving the illusion that the aurora is rising like a flame whipped upward by wind. But there is no wind at that altitude, only electrons following magnetic paths. The motion is so fast that the human eye struggles to track it. A bright band may form across the horizon, one moment rip and dissolve the next, only to reappear behind you with new shapes. We are watching the edge of a storm that exists in plasma, not air. Then there is the braiding. During some displays, especially substorms, the auroral curtains twist around themselves like strands of hair woven by an invisible hand. These braids form when streams of electrons follow adjacent field lines that begin to oscillate or rotate relative to each other. The ribbons of light twist because the magnetic geometry itself is twisting. It is a cosmic braid light woven around force woven around the Earth, and sometimes the braids suddenly straighten as if pulled taut, before dissolving into a shower of small ripples. This is the aurora responding to sudden changes in magnetospheric tension. When magnetic field lines snap back into place, after stretching too far, the aurora behaves like cloth pulled tight then released. The sky trembles, the light flickers, the entire curtain shivers as though alive. Another astonishing feature appears during strong geomagnetic events, the bright teeth, also called Rayed breakup arcs. These jagged bursts appear when the electron precipitation intensifies in narrow vertical channels. Each tooth is a ray, an individual magnetic field line suddenly lit by a torrent of descending electrons. Hundreds of these rays can brighten at once, creating a comb-like structure that flashes in and out of existence. From the ground, it looks like the aurora is bearing fangs, light sharpening into luminous spikes. In reality, it is the magnetosphere releasing energy with explosive efficiency. These teeth often mark the beginning of an auroral breakup, the moment when the quiet arcs rupture into chaotic, fast-moving forms. The entire curtain becomes turbulent. Waves race through the structure at astonishing speeds. Bright patches appear and vanish as if the sky were breathing too quickly to keep still. It is during these moments that the aurora feels most alive, most like an organism made of light. The motion carries purpose. The shapes respond to forces we cannot see. The silence becomes eerie because the mind expects sound to accompany such violent, swift changes. And yet nothing. Not a whisper. Not a crack. Only the faint rustle of wind at ground level, far disconnected from the drama above. Scientists studying these motions use terms like electrostatic waves, Alfvén waves, and field-aligned currents. But even these precise descriptions cannot fully capture the experience of watching the aurora move. The physics is vast and intricate, involving magnetic reconnection in the magnetotail bursts of plasma energy and rapid reorganizations of the field. But what the human eye perceives is simple primal light behaving like a creature. Sometimes it pulses rhythmically like a heartbeat racing through color. Sometimes it unfurls in spirals, turning the night into a slow dance. Sometimes it lashes across the sky in a violent wave, then softens into delicate ripples. One of the most surreal illusions is the curtain fold, where the aurora appears to sway back and forth, as though thick fabric were being shaken. But the air is too thin for wind to play any role. The motion comes from shifting precipitation zones, bright regions where electrons are falling more densely. When these zones shift quickly, the aurora looks like it is folding and unfolding. When they shift slowly, it appears to breathe. From space, astronauts see this motion from above: spirals, uncoiling arcs, drifting bright patches expanding like luminous cells in a living organism. They describe the aurora not as a curtain, but as a lake of light spread across the poles, stirred by invisible tides. From the ground, the illusion is vertical, from orbit horizontal, but in both cases it conveys life. Some observers speak of an instinctive feeling, an ancient recognition that the aurora is not just color but presence, something active, something watching, moving, responding. And perhaps that feeling is not mistaken, because what we see in the sky is not passive light. It is the Earth's magnetic field in motion. It is the solar wind finding a path into our atmosphere. It is the planet and the star interacting in real time. Every ripple is the echo of a magnetic wave. Every flicker is a shower of electrons arriving from space. Every flash of teeth marks a moment of tension released across millions of kilometers. The aurora is movement made visible, the choreography of a cosmic storm translated into color. Tonight, if the sky brightens and the ribbons begin to race, watch how they move. Silent lightning, light that leaps without warning, a storm without thunder. The aurora's motion is the heartbeat of the invisible world above us, a reminder that even in stillness the universe is alive. Far behind the Earth on the side, turned away from the sun, stretches a long invisible structure that few people ever think about. It is the magnetotail, the distant extension of Earth's magnetic field, drawn out like a shimmering ribbon by the solar wind. This tail is enormous. It stretches for millions of kilometers into space, longer than the distance from Earth to the Moon. It is our planet's shadow, not made of darkness, but of magnetism. Most nights the magnetotail is quiet. Its field lines drift gently through the vacuum, curved like long strands of silk trailing behind a lantern. But during a solar storm, when the incoming wind presses hard against the front of the magnetosphere, the tail tightens, it stretches, it fills with energy. Imagine bending a flexible branch almost to the point of breaking. That is what happens to the magnetic field behind Earth. And like a branch under tension, there comes a moment, sudden, precise electric, when the tail can no longer hold its shape. It snaps. This snapping is not an explosion in the ordinary sense. It is magnetic reconnection, one of the most powerful and mysterious processes in the universe. When magnetic field lines are pushed together under extreme pressure, they can break, rearrange, and rejoin in a new configuration. In the process, energy stored in the bent field is released violently and suddenly. To human eyes, nothing is visible, but in the magnetosphere, the rearrangement is like a whip cracking across space. Earth's magnetotail becomes momentarily transformed. Particles that were drifting slowly now surge forward. Currents intensify. Energy rushes toward the planet in a fast, downward spiraling cascade. The aurora reacts instantly. A quiet arc across the polar sky suddenly brightens, sharpens, and fragments. Ribbons burst into motion. Waves ripple upward. Teeth flash at the edges. The entire display becomes turbulent, wild, alive. This is the moment many aurora watchers instinctively feel the shift from calm to storm, from drifting light to urgent motion. It is the Earth answering a magnetic rearrangement that happened hundreds of thousands of kilometers away. And astonishingly, this process connects us to some of the most extreme environments in the cosmos. Magnetic reconnection is not unique to Earth. It is woven into the fabric of the universe. On the Sun, reconnection triggers solar flares, bright flashes that can outshine the entire solar surface in an instant. Field lines in the Sun's corona twist until they snap, releasing enough energy to heat plasma to tens of millions of degrees. Solar flares are reconnection writ large, the Sun's own magnetic skeleton realigning itself in bursts of brilliance. Near black holes, reconnection drives jets, narrow beams of near-light-speed particles, shooting thousands of light-years into space. The swirling disks of matter around black holes are full of tangled magnetic fields, constantly stretched and twisted by the screaming fast rotation. When those fields reconnect, they hurl material outward in beams brighter than galaxies. In neutron star magnetospheres, places where the magnetic field is strong enough to tear atoms apart, reconnection events produce gamma-ray flashes so intense they can momentarily outshine anything else in the sky. In all of these places, the pattern is the same: fields bend, fields break, and the universe responds in light. Earth's magnetotail does the same thing, but gently on a human scale. The physics is identical, the stakes are simply smaller. Yet there is something profoundly comforting in this. Our planet participates in the same cosmic processes that shape galaxies and stars. The night sky above the Arctic whispers the same language spoken in the hearts of distant suns. When the magnetotail snaps, the rearranged field sends charged particles racing back toward Earth. These electrons and ions follow magnetic lines that curve down into the polar atmosphere. When they arrive, they meet oxygen and nitrogen, sparking the familiar glow. But because the energy release is sudden, the aurora becomes much more dynamic. A single reconnection event can trigger a brightening of the entire arc, as if a dimmed sky were turned up by a hidden dial. Rapid waves travelling along the curtain, racing upward at incredible speeds. Fragmentation of the arc into braid spirals and darting patches of light. A full auroral breakup where the calm glow erupts into explosive motion. Aurora researchers often describe this stage as the sky waking up. Though the truth is reversed, the sky is simply reflecting the awakening of the magnetotail. The sequence is captivating. Compression. The solar wind pushes the magnetosphere, stretching the tail. Energy loading. Magnetic field lines in the tail bend and store tension. Reconnection. The lines snap and reconnect, flinging particles toward Earth. Auroral breakup. The lights erupt into rapid, complex motion. Recovery. The tail relaxes, the aurora calms, and the quiet arcs return. You can almost think of it as Earth having a heartbeat. A pulse of energy builds, then releases. The aurora is the skin flushed with color in response. If the magnetotail could speak, it might say, "I bend, I break, I return." But the process is not simply mechanical. It is delicate, sensitive to the smallest changes in the solar wind. A shift in the interplanetary magnetic field can alter when and where reconnection begins. A slight rotation of the field can delay the onset of a substorm by minutes. The magnetotail is like a long taut string played by the fingers of the solar wind, responding to pressure, rhythm and angle with remarkable precision. Sometimes reconnection happens far down the tail, deeper in space. Sometimes it happens closer, sending particles more directly toward Earth. The difference can shape the night, a quiet glow versus a sky in full motion. All of this unfolds silently above us in a realm we cannot touch. Yet the result feels intimate. A person standing on a frozen lake watching the aurora suddenly erupt in brightness is witnessing the echo of a cosmic process that began 250,000 kilometers behind the Earth. A process that also powers the flares on our star. A process that shapes the disks around black holes, a process older than planets themselves. And yet here on Earth it ends as a ribbon of green light drifting across the sky. The magnetotail snaps, the planet glows, night becomes luminous, and the universe once again reveals how its grandest forces can express themselves in the gentlest signs. At first glance, the aurora seems simple, a soft green glow, a graceful arc, a quiet river of light. But the sky has many moods, and the aurora wears many faces. Sometimes it drapes itself in broad flowing curtains, other times it splits into narrow filaments, sharp and crackling like wires pulled through the dark. The difference between these forms is more than appearance. It is a story of structure, motion, and the invisible forces shaping the night. The most familiar shape is the auroral curtain. Long, smooth and flowing, it stretches across the horizon like a fabric unfurled by unseen hands. These curtains can be hundreds of kilometers long, rising vertically from the atmosphere like glowing walls. Their movement is gentle ripples, folds, graceful sways that mimic the motion of silk caught in a slow breeze. These smooth curtains form when electron precipitation is broad and uniform, when entire bundles of magnetic field lines are illuminated evenly. The energy arrives like a steady stream, filling the sky with a soft, coherent glow. From a distance, the curtain looks almost two-dimensional, a sheet of light that shifts but never breaks. But approach closer, or wait for the sky to grow restless, and the aurora begins to reveal finer textures. The smooth surface separates into narrow ribbons, each one only a few kilometers wide but stretching endlessly upward. These ribbons shimmer with more intensity. They pulse, they twist, they appear and vanish in seconds. If the curtain is silk, the ribbon is braided wire. Each ribbon is the glow of electrons pouring down a specific magnetic field line. Instead of a broad flow, the precipitation becomes filamented, channeled into thin, concentrated paths. The aurora becomes textured, almost muscular, as if the sky is showing the tendons beneath its luminous skin. In the calmest nights, the distinction between curtain and ribbon is subtle, but during a geomagnetic storm, the difference becomes dramatic. The curtains widen like rivers of light flowing steadily across the sky. The ribbons crackle like sparks racing through the curtain's surface. These two forms coexist, merging and separating again as the magnetosphere rearranges its energy. Imagine the curtain as a slow-moving river, full and calm, drifting without urgency. Now imagine the ribbon as the bright foam at the river's edge, swift, sharp, restless. This contrast is not only poetic, it is physical. Curtains reflect broad precipitation from stable plasma flows. Ribbons reveal fine-scale turbulence instabilities and sharper currents. You can almost feel the difference just by looking. The curtain breathes, the ribbon vibrates. Some nights the ribbons twirl into spirals, braiding themselves like strands of rope. These spirals form when magnetic field lines twist, or when plasma waves ripple through this magnetosphere. The light follows the twist, revealing the shape of fields that would otherwise be invisible. Other nights the ribbons race upward as if climbing into space. This upward motion is not the light itself travelling, but a wavefront of precipitation sweeping along magnetic field lines. The effect is startling. The ribbon seems alive, ascending through the air with the urgency of a spark leaping along a fuse. In the seconds before a substorm breaks, ribbons often gather at the bottom of broad curtains, forming bright needle-like structures. These are rays, thin filaments marking individual field lines. When energy suddenly intensifies, the rays flare all at once, creating a row of luminous spikes, the teeth that signal the beginning of auroral breakup. The contrast between the smooth curtain and the crackling filament becomes unmistakable. The curtain glows with sustained color. The filament snaps, flares, curls, and vanishes. Silk meets wire, river meets spark. From space satellites, see these structures from above. Curtains appear as long arcs sweeping across the poles. Ribbons appear as bright, narrow streaks with sharp edges. When a storm is strong, tens of thousands of ribbons can form simultaneously, turning the auroral oval into a luminous web. Where field lines bunch together, ribbons thicken. Where they spread apart, ribbons split into branching strands. Some nights the ribbons are so numerous that the sky resembles a harp. Dozens of glowing strings aligned vertically, humming with silent energy. Each string marks the path of electrons spiraling down magnetic lines into the atmosphere. Together they form the skeleton of the aurora, the underlying geometry beneath the flowing curtain. And then there are the rare shapes. Warped curtains that twist like torn fabric. Rayed arcs that look like the ribs of a fan. Picket fence auroras, parallel bars of green and purple rising from the horizon. Curls and eddies that mimic the patterns of wind in grass. These forms emerge from plasma instabilities, Kelvin-Helmholtz waves, shear flows, drifting currents, phenomena more at home in the edge of space than in the air we breathe. But from the ground they feel strangely familiar, as if the sky has borrowed its shapes from watercloth or fire. The aurora echoes natural forces we know, even as it is shaped by forces we cannot see. One of the most breathtaking forms is the veil, a faint smooth glow that drapes across the sky like thin silk. No sharp edges, no flickering lines, just a soft radiance. Veils appear when precipitation is light and spread across many field lines at once. They mark the quiet, reflective phases of auroral activity, the moments when the magnetosphere is catching its breath. At the opposite extreme are vortex spirals, swirling shapes like luminous whirlpools. These form during intense reconnection events, when plasma flows diverge and twist. In these moments, the aurora looks like water swirling down a drain, or clouds spiraling into a storm, except this storm happens in silence, in color, in the upper atmosphere. Yet whether calm or turbulent, smooth or filamented, every aurora shares the same source, electrons, pouring down magnetic pathways guided by a field shaped by the sun, meeting the air we breathe and releasing energy as light. The beauty lies not only in the variety of shapes, but in how seamlessly the aurora transitions between them. A wide curtain may suddenly fracture into a dozen ribbons. Those ribbons may curl into braids. The braids may dissolve into a veil, and the veil may brighten back into a curtain again, all within minutes, all without a single sound. The sky shifts from cloth to wire, from river to spark, from breath to heartbeat. It is a reminder that the aurora is not one phenomenon, but many a living spectrum of forms shaped by the invisible interplay between Earth and the Sun. Tonight, if the lights appear, take a moment to watch how they form. See the smooth curtain first, wait for the ribbons to emerge, watch how the spark traces itself across the river of green. You will be witnessing the sky reveal its many faces, each one a luminous expression of the forces that surround our world. There are nights when the aurora moves gently, drifting in slow folds like a curtain stirred by distant tides. And then there are nights when something stranger happens, something almost too quick for the human eye to grasp. The sky begins to flicker, not once, not twice, but 10 times every second. A trembling shimmer, a rapid pulse, a quickening breath written in light. To someone standing beneath it, this flicker feels uncanny. Light shouldn't move like that. The heavens shouldn't ripple with the urgency of a heartbeat. Yet the aurora, usually a creature of broad motion and sweeping shapes, can shift into this rapid mode when the magnetosphere begins to vibrate with high-frequency waves. This is the aurora at 10 Hz, 10 pulses per second, a shimmer that makes the sky look alive in a new exhilarating way. The flicker begins far above the glowing air in the realm of plasma waves. The magnetosphere is not empty space. It is filled with charged particles, electric fields, magnetic currents, and a network of waves that ripple invisibly through the darkness. These waves come in many frequencies, from slow undulations taking minutes to oscillations so rapid they occur dozens of times each second. When those high-frequency waves modulate the flow of electrons plunging toward the Earth, they stamp their rhythm into the aurora. The electrons arrive in pulses 10 pulses per second, and the atmosphere responds instantly. Oxygen and nitrogen atoms light up in that same rhythm, glowing and fading, in a pattern too fast to follow consciously, but fast enough to feel. The result is a sky that quivers. It does not shake like a flag or rattle like a window. It shimmers subtle, quick electric. To many observers, this flicker feels like the sky breathing quickly, inhaling and exhaling in tiny bursts. The aurora brightens as the electron flow increases, dims as it decreases, then brightens again before the mind can register the change. Each pulse is only a fraction of a second, but they follow each other so reliably that the entire curtain beats with a rapid rhythm. If the calm aurora is a long, slow breath, this is panting, quick, tense, urgent. And yet the flicker remains silent. The only sound is your own breath catching in the cold. From a scientific perspective, this flicker is evidence of Alf-Venn waves, magnetic oscillations traveling along Earth's field lines like vibrations along a string. These waves can accelerate electrons, modulating their energy and guiding them downward in pulses. They're named after Hannes Alf-Venn, the physicist who first described the behavior of plasma threaded by magnetic fields. When these waves oscillate at around 10 Hz, the electrons they energize arrive in matching bursts. The aurora becomes a glowing readout of the magnetosphere's frequency. It's strange to think that the sky above you is blinking in time with a magnetic wave rippling through space. But this is the nature of the aurora. It is the visible surface of a vast invisible ocean of plasma. Some nights the flicker appears only at the edges of the curtains, tiny ripples that make the ribbons sparkle. Other nights the entire sky seems to quiver, as though the aurora has been transformed into a shimmering mesh of vibrating light. To humans, 10 Hz is a peculiar frequency. It sits near the threshold where flicker becomes sensation rather than conscious perception. It is fast enough that the mind does not see individual flashes. It sees shimmer. It is slow enough that the flicker feels palpable, almost tactile. Standing under such a display, you may feel something in your chest, respond a subtle tension, as if your heart is trying to match the sky's pace. The flicker is not sound, not touch, not wind, but it is presence. It gives the aurora a pulse. In time-lapse footage, the flicker becomes even more pronounced. The sky seems to race and quiver, the light flashing like electrical current traveling through a circuit. But in real time, the effect is smoother, more like the surface of a lake disturbed by dozens of tiny fish, each sending ripples outward faster than the eye can follow. The emotional effect is powerful. There is urgency in the flicker, there is excitement. There is a sense that the aurora has shifted into a higher gear, and yet even here the underlying structure remains the same. The flicker traces magnetic field lines. The shimmer follows the boundaries of precipitating electrons. The rhythm echoes the waves traveling through the magnetosphere. The sky is not randomly blinking. It is responding to a precise physical signal. During strong geomagnetic storms, the flicker can intensify, forming sharp bursts of light, tiny flashes that dart across the curtains like sparks running along wire. This is the high-speed edge of auroral physics, where small-scale instabilities in the plasma cause rapid changes in brightness. Scientists studying this phenomenon often use high-speed cameras capable of capturing hundreds of frames per second to analyze the fine details. Those cameras reveal something remarkable. What looks like a continuous shimmer to the naked eye is an intricate pattern of microbursts, wavelets, and modulated flows. The aurora is flickering differently in different parts of the ribbon. The flicker travels. The flicker clusters. The flicker dances. It is like watching millions of tiny lights playing tag with each other across the sky. And through it all, the Earth and Sun remain connected. The flicker is the signature of the invisible bridge between them, a rhythm carried across millions of kilometers of space translated into pulses of color in our upper atmosphere. Some nights the flicker comes and goes quickly. Other nights it holds for minutes, turning the aurora into a trembling veil. To ancient watchers, this behavior must have seemed mystical. Lights that moved like breath. Lights that pulsed like life. Lights that shimmered in rhythms too fast to explain. To modern observers, it still feels extraordinary. Even knowing the physics, the experience does not lose its wonder. For in that shimmering sky, 10 pulses every second, you are witnessing something intimate. The heartbeat of the magnetosphere made visible, the quick inhale of a planet touched by solar wind, the silent trembling of Earth's magnetic skin. Tonight, if the aurora appears and begins to flicker, take a moment to be still. Watch the quick shimmer. Feel the rhythm. Let the sky breathe above you, not slowly but quickly, urgently, beautifully. You're seeing the world respond to a cosmic vibration. You're seeing the night tremble with the touch of space. From Earth, the aurora rises above us, an arc, a curtain, a ribbon. But from orbit, the entire geometry reverses. Astronauts do not look up into the aurora. They look down into it. They float above a world wrapped in slow-moving fire, gazing directly into the heart of a luminous ocean spread across the poles. From this vantage, the aurora becomes something far larger, far deeper, far more otherworldly than any ground-based observer ever sees. Imagine drifting around the curve of the Earth at 28,000 kilometers per hour. Night sweeps across the Pacific. A dark hemisphere rises ahead. And then there it is, a ring of green light glowing like the rim of a great bowl encircling the planet's pole. The aurora no longer looks like a single arc, but a vast continuous halo, a shimmering crown, a planetary necklace of drifting emerald and rose. Astronauts often say that from space, the aurora looks like the planet is wearing its own atmosphere as jewelry, living, glowing, moving. When the spacecraft passes above the light, the ocean metaphor becomes impossible to ignore. The aurora spreads below like a sea of luminous waves, each ripple a magnetic field line, each crest a burst of electron precipitation. It is not a flat sheet, but a three-dimensional landscape, a glowing terrain rising hundreds of kilometers above the surface. From below, the aurora feels tall, from above it feels deep. Looking down is like gazing into a gorge of light, or into the heart of a translucent cloud lit from within. Astronauts see layers green at the lower boundary, red floating above it like a diffuse haze, and thin, sharp filaments of purple threading through the structure like electric veins. Sometimes the spacecraft skims the very edge of this ocean. In those moments, astronauts fly through the aurora. They report the strangest feeling traveling through a silent, luminous fog. The glow seems to envelop the windows. Colors spill across the cockpit like mist, lit by underwater lanterns. The light appears close enough to touch, though the air outside is almost non-existent. There is no sound, no vibration, only the passage of color drifting and shimmering like phosphorescence in deep water. Some describe it as flying through a ghost made of the light. Others describe it as skimming the surface of a living sea. One astronaut once said it feels like Earth is exhaling light, and we're passing through its breath. From this high vantage, the origin of the aurora becomes easier to see. The magnetic field lines curve like gigantic threads connecting space to Earth, and the aurora appears exactly where those threads pierce the atmosphere. It becomes obvious that the lights are not random. They trace the architecture of the magnetosphere with astonishing clarity. The auroral oval takes on form and meaning. It is no longer a vague concept, but a real physical halo glowing around the poles. When a geomagnetic storm intensifies, astronauts see the oval expand outward, like a tide rising along the edge of a continent. The waves of light spread, surge, retreat Earth, conducting energy between space and air. During strong storms, the ribbons become so bright and complex that they resemble lightning frozen in place. Some curtains rise hundreds of kilometers above the surface, forming towering walls that stretch toward the spacecraft like luminous mountain ranges. These walls flicker and curl in silence, transforming Earth's edge into a shimmering boundary between world and cosmos. The planet's night side, normally a sphere of quiet darkness punctuated by city lights, becomes a glowing hemisphere of drifting color. The aurora illuminates the atmosphere from above, painting the limb of the Earth. With a thin, bright green line, the atmospheric edge lit like a neon horizon. Seen from space, this line is impossibly delicate. a fragile halo over a vast dark sphere, a reminder of how thin our atmosphere truly is. Astronauts often talk about how the aurora reveals Earth's vulnerability. Beneath this glowing membrane lies everything we know: oceans, forests, cities, winter storms, deserts, and all the life that has ever lived. Above it lies vacuum and silence. The aurora marks the border between the two, the skin of the planet shimmering under the touch of the sun. When the spacecraft crosses directly above the aurora, astronauts see something ground observers can never witness: the tops of the curtains. From above, these curtains look like waterfalls of light flowing downward, streaming toward the surface. The long rays that appear vertical from the ground now look like pillars leaning toward the world below. The flickers and pulses become easier to detect. The waves run outward like ripples traveling across a lake. The breakup arcs appear as bursts of brightness spreading like sparks through mist. The whole auroral oval seems alive with motion, alive in a way that is difficult to describe from below. From the ground you see slices of the aurora. From orbit you see the whole mechanism breathing. Sometimes the spacecraft flies directly through an upward surge, a collapsing magnetic wave sending particles outward. In those moments, astronauts see faint flashes all around them like glittering dust illuminated by starlight. It is not dangerous. The station is shielded. But the visuals are unlike anything on Earth. It is like flying through the embers of an invisible fire. And then there is the moment that many astronauts remember most vividly, drifting out of the aurora and into the pure darkness beyond it. The ocean of light falls away, shrinking into a bright ring encircling the pole. The Earth rotates slowly beneath, and the sun peeks over the horizon, a thin blade of gold cutting through the dark. Above, space grows quiet and infinite. The aurora remains behind, glowing softly like the memory of a dream. Some astronauts describe a feeling of deep calm when leaving the aurora behind. Others describe a sense of awe, not for the aurora itself, but for the fact that such a delicate, beautiful thing is the visible trace of cosmic forces that span millions of kilometers. From Earth, the aurora looks magical. From space, it looks inevitable, a natural expression of the Earth-Sun relationship, a luminous handshake between worlds. Tonight, if you watch the aurora from the ground, imagine what it looks like from above. Imagine seeing the full halo, the glowing ocean, the drifting veils. Imagine flying through the light and emerging into stillness. Because above the aurora, the Earth wears its crown not as a spectacle but as a quiet pulse, a reminder that our planet is alive, connected, and dreaming in color. When you stand beneath the aurora, it feels intimate, something close, something personal. A ribbon drifting above the tree line, a green river flowing just beyond the horizon, a curtain of light rising like a silent prayer into the night. But the scale is an illusion. The aurora is far larger than it ever appears from the ground, larger than countries, larger than seas, sometimes larger than continents. Above the Earth, where satellites drift quietly, the ovals of auroral light spread like vast glowing crowns around each pole. They are not small rings. They are wide, soft halos that stretch for thousands of kilometers in every direction. From orbit, you can see the light curling over half of Canada, sweeping across Alaska, brushing Greenland, touching Siberia, all in a single unified arc. In the southern hemisphere, another arc just as large spreads over Antarctica, glowing across ice sheets bigger than entire nations. What looks like a narrow band from a snowy field in Norway is from above a structure spanning from horizon to horizon, an atmospheric continent of color. Each ribbon you see is only a tiny piece of a sprawling architecture. Auroral ovals expand and contract as the solar wind strengthens or weakens. During quiet nights, the oval hugs the poles, closely forming a tight ring. But during geomagnetic storms, when the sun sends faster or denser streams of charged particles, the oval swells outward. It pushes southward in the northern hemisphere, northward in the southern. It grows wider, thicker, brighter. This is how cities far from the Arctic, like Edinburgh or Seattle or Beijing, occasionally find themselves under a glowing sky. It is how entire regions, millions of people separated by mountains and seas, look up on the same night and see the same light. The aurora is not something local. It is something that happens to the whole planet. During the strongest storms, the oval can stretch across the continental United States painting skies from Oregon to Oklahoma, from Maine to the Carolinas. It can cover all of Scandinavia and reach deep into Central Europe. In the south, it can brush the coasts of Australia and New Zealand, glowing across oceans in a way that feels unreal. an Antarctic curtain seen from lands warmed by subtropical winds. These storms remind us that the aurora is not a small spectacle, it is a planetary-scale event. Imagine looking down on Earth at such a moment. The night side of the planet comes into view, and all at once entire countries shine with drifting green, not in one valley, not above one frozen lake, but across whole landscapes, mountains, plains, rivers and cities touched at once by the same cosmic breath. There is a quiet unity in this. On those rare nights, millions of people who do not know each other, who speak different languages, who live different lives, step outside and look up. The same light touches their faces, the same sky moves them. There is something comforting in that shared moment, something ancient and human. Because long before we understood the science, we understood the feeling. The sky glows and we gather, the sky moves and we listen. The sky changes and something inside us changes with it. Even today, with satellites and sensors and orbiting observatories, that feeling remains. Scientists see numbers, electron flux, magnetic indices, solar wind velocities, but the world sees light, the world sees colour, the world sees something that makes us feel small in the best possible way. The scale of the aurora is not just physical, it is emotional. Standing on the ground, the horizon hides its true size. You see slices, fragments, narrow arcs. But in reality, the aurora stretches across distances that would take days to travel. It spans entire cultures, climates and histories. In Greenland, hunters lift their eyes from the dog-sled tracks. In Finland, children press their faces to frosted windows. In Alaska, fishermen pause before dawn. In Scotland, camera lenses point to the dark sea. In Mongolia, herders step outside into the cold. In Japan, watchers gather on Hokkaido's cliffs. Different worlds, one sky. And above them all, the aurora moves as a continuous whole. The light you see might be the same moment of brightness seen by someone 1,000 kilometers away. The pulse of green that ripples above you might be part of a wave crossing a distant country. You're seeing the edge of something enormous, something shaped by global magnetism, by solar energy, by the geometry of the entire Earth. The aurora feels like an emotion stretched across continents, a whisper shared by millions, a breath taken together by the poles of the planet. And yet even this is not the full story, because the aurora also rises into space. If you floated above it, you would see layers of light stacked like luminous atmosphere, green at the bottom, red above it, purple filaments etching the edges. The whole structure towers upward for hundreds of kilometers. The true aurora is not just long across the Earth's surface, it is tall, a glowing mountain range of air. When the oval expands, the scale becomes almost unfathomable. A single bright surge can illuminate an area larger than India. A major substorm can light up a region the size of all Scandinavia combined. The aurora can stretch from Iceland to Siberia in a single arc. It can span the entire South Pacific in graceful curves. And when the oval contracts, the giant halo pulls back toward the poles, returning to a quieter, tighter ring. The cycle repeats night after night, following the rhythms of the sun's breath. The Earth glows, the Earth dims, the Earth glows again. The true size of the aurora isn't measured only in kilometers. It's measured in people who look up, in regions touched by the same color, in nights where whole nations share a moment of wonder. Tonight, if the lights appear, try to imagine how far they reach. Try to picture the curved earth beneath them glowing softly at the top and bottom like a lantern. Try to see not the ribbon above you, but the continent-wide crown it belongs to. Because the aurora is not a local miracle, it is a planetary one. A light big enough to connect strangers, wide enough to bridge oceans, vast enough to turn the whole Earth into a single shared sky. To the human eye, the aurora is a mystery of green-red and the faintest hints of purple. Its palette feels complete, soft rivers of emerald, slow veils of crimson, quick sparks of violet. But this is only the smallest slice of its true spectrum. There are colors in the aurora that no human has ever seen with unaided eyes. Colors that shimmer quietly beyond our biological limits. Colors that exist yet arrive at our minds only through machines, cameras, sensors, and instruments tuned to wavelengths our eyes cannot reach. To understand why, we must first understand the limits of vision. Human eyes evolved for daylight. Our retinas use two systems, cones which see color in daylight but struggle in darkness, rods which dominate in night vision but cannot see color at all. When the aurora glows above us, rods do most of the work. They are far more sensitive to dim light, but almost blind to red and blue wavelengths. This is why most people see green vividly, but struggle to see the deeper reds and blues unless the aurora grows extremely bright. When an aurora is faint, we often perceive it as white. When it is moderate, we see green. Only when it intensifies do the purples, blues and reds sharpen into reality. Our eyes are working with narrow bandwidth, limited sensitivity and slow response times. Cameras are not. The camera's world, a wider spectrum. A digital sensor, unlike the human retina, does not switch between night and day modes. It is always ready to absorb colour across a wide range of wavelengths, even weak signals register. Purples the eye dismisses as grey become vivid on a sensor. Reds too faint for rods appear rich and warm. Blues hidden at the curtain's edge brighten into luminous streaks. A camera does not tire. Its rods and cones do not trade places. It sees all wavelengths with equal patience. This is why photographs of auroras sometimes feel unreal. The colours are real, nothing is being added, but they are colours that the sky emits more subtly than our eyes can capture in the moment. In long exposure images, the sensor gathers light over seconds, sometimes over minutes. While the human eye samples light continuously at fractions of a second, a camera collects colour patiently. It adds every photon to its memory until faint hues become bright enough to be seen. Long exposure turns whispers into words. It turns invisible colours into images. It shows a sky that was always there, just beyond the reach of biology. Ultraviolet auroras. Light. Beyond vision. The aurora does not glow only in visible colours. It shines in the ultraviolet too, a spectrum the human eye cannot perceive at all. Ultraviolet auroras often form high above the green and red layers near the edge of space. They come from nitrogen molecules excited by energetic electrons emitting wavelengths too short, too sharp for our retinas to register. Spacecraft such as the Image satellite, the Polar spacecraft and now newer missions have recorded these ultraviolet auroras in astonishing detail. Seen through their instruments, the aurora becomes a different creature entirely, a glowing halo of ghost light, a crown emitting in hues no human life has ever directly experienced, a silent ultraviolet flame embracing the poles. To ground-based observers, these auroras are invisible. To orbiting sensors, they reveal the hidden architecture of energetic storms. Some ultraviolet emissions outline the auroral oval with sharp precision. Others trace storm boundaries that are invisible in green or red. In UV, the aurora becomes a diagnostic tool, a map of the magnetosphere's activity written in colours we cannot see. Infrared glows, ghosts of heat. Even stranger, the aurora also glows in the infrared, though faintly. Infrared is the light of warmth, wavelengths longer than red, emitted by vibrating molecules. In the high atmosphere, excited nitrogen and oxygen release this heat light after collisions. The glow is too dim and too long in wavelength for the human eye, but infrared sensors detect it clearly. In infrared imagery, the auroral oval becomes a ring of warmth along Earth's upper atmosphere, a delicate pulse of heat spreading across the night side. It shows up not as a bright flame, but as a warm shimmer, the kind of glow a camera tuned to temperature can perceive. To humans, invisible. To instruments, a new language of the sky, the hidden blues and violets. Even within the visible spectrum, the aurora hides. Human night vision strongly favours green, while cameras capture blues and purples easily. This is why photos often show a deep violet fringe that appears only faintly to the naked eye. Neutral nitrogen emits rich violet wavelengths. Ionized nitrogen emits a deep electric blue. But our rods struggle badly with these colours in darkness. To us, the lower fringe looks like pale grey. To a camera, it looks like glowing ice. A long exposure photograph reveals a world our eyes can barely sense, a shimmering lavender boundary, drawn in precise, delicate strokes. Why technology shows more. In a sense, cameras do not see more than we do. They see with different limitations. They build light slowly, the way memory builds meaning. They store photons the way water gathers in a still pool. They reveal the aurora as a composite of time, not a single flash of perception. Our eyes evolve to survive. Cameras evolve to record. The aurora rewards both. Hidden dimensions of a living sky. The sky above you is far richer than you perceive. While you watch a green curtain drift across the stars, the atmosphere is glowing in ultraviolet above it, shimmering in faint reds around it, flickering in blues beneath it. and releasing infrared warmth long after each electron's journey ends. It is a spectrum layered like a living tapestry. Visible green pouring from oxygen atoms at 100 kilometers, visible red floating higher above, violet filaments framing the edges, ultraviolet currents shimmering unseen, infrared warmth spreading through the rarefied air, a cathedral of light built across wavelengths, a sky singing in colours our biology cannot hear. The emotional mystery, knowing without seeing. There is something profoundly moving about. Knowing the aurora is larger than us not only in size but in colour. Something humbling in realising the sky glows in hues our ancestors never knew that entire realms of light pass silently above us without entering our eyes. We live inside a world richer than we can perceive. Technology lifts the curtain gently, respectfully, and shows us a few steps further. But the mystery remains. Even with sensors, we see only slices. Even with cameras, we glimpse only reflections. The aurora keeps its full spectrum to itself, an expression of a world beyond human limits, a reminder that our senses touch only the surface of the universe. Tonight, if you stand beneath the aurora, take a moment to imagine all the colours you cannot see. The ultraviolet crown, the hidden blues, the faint infrared glow dissolving into space, invisible yet present, unseen yet real, silent yet full of meaning. The aurora is bigger than our eyes, and yet it welcomes us gently into its smallest visible part. There is a strange contradiction at the heart of the aurora. It is born from storms on the sun, storms in the magnetosphere, storms made of charged particles and electric tides. Energy travels millions of kilometers. Magnetic fields snap and reconnect. Electrons rain into the atmosphere with the speed of lightning. And yet, when the aurora finally reaches us, when it paints the night sky in sweeping curtains and trembling flickers, there is no sound. None at all. You can stand beneath a sky alive with motion, a sky shifting and pulsing like a great cosmic heartbeat, and the world will remain silent. The snow crunches under your boots. Your breath clouds in the cold, but the lights themselves, those vast moving rivers, never whisper, never crackle, never roar. The aurora is the quietest storm on Earth. That silence is one of its deepest mysteries. Everything about its creation seems to demand noise, electricity collisions, waves racing through space. But the aurora forms high above the ground in air too thin to carry sound. The glow you see comes from atoms releasing photons, not from anything that could stir air or vibrate it into sound waves. To the physics, the silence is inevitable. To the heart, it feels impossible. Human beings are used to storms that announce themselves, thunder, wind, rain, the growl of oceans. But the aurora is a storm that hides its violence. It reveals only the light, never the force. Perhaps that is why it feels so dreamlike. A world in motion, a sky alive, yet not a single whisper reaches your ears. But this silence, profound and unbroken, has shaped human imagination since the first people looked up into the polar night. Voices in the lights. For many ancient cultures, the aurora was not silent at all. The Sami people of northern Scandinavia believed the aurora carried spirits, sometimes ancestors, sometimes something more fearsome. They were warned never to whistle beneath the lights, not because the aurora was loud, but because whistling might cause it to respond. In parts of Greenland, hunters spoke of hearing faint crackles when the lights moved quickly, as though the sky itself were brushing against something unseen. The Inuit told stories of the aurora as playing fields where spirits tossed a walrus skull back and forth, the game echoing through the night as faint, distant sounds. In Finland, the lights were called revontule, the fox fires. It was said that a great Arctic fox racing across the tundra swept its tail through snowdrift so quickly that sparks flew into the sky. When the aurora rippled fast, some listeners claimed they heard faint rustles, as if the fox was still somewhere near tail sweeping sparks rising. Many indigenous peoples of North America spoke of voices soft, distant, like murmuring, a conversation at the edge of hearing, the kind of almost sound that tingles just behind the mind but never clearly arrives. Were these stories metaphor, memory, imagination, or was something else happening? The rare sound of light. For centuries, scientists dismissed auroral sounds as myth. The aurora was too high, 80, 100, 200 kilometers above Earth for sound to travel. The air was too thin, the physics too clear, and yet people continued to report them. Not loud, not clear, not musical, but subtle noises, crackles, faint hisses, tiny pops like distant static. Only recently have researchers begun to uncover a possibility during certain conditions, cold, calm, still nights, electric discharges can occur near the ground. Not from the aurora itself, but from the way geomagnetic storms disturb Earth's electromagnetic environment. When atmospheric layers change rapidly in charge, small local discharges may spark just meters above the surface, producing sounds in sync with auroral movement. These electrophonic sounds are faint, barely detectable but real. So perhaps the ancient stories were not wrong. Not literally the aurora making sound, but the world beneath it answering in tiny sparks. A kind of earthly echo of a cosmic event. Still, these sounds are exceedingly rare. For most people on most nights, the aurora remains completely silent. Silence as presence. Stand beneath the aurora long enough and you begin to feel the silence physically, not as an absence, but as a presence. The air seems to hold its breath. The land seems still. Even the smallest noises, your breath, your clothing, the crunch of snow become amplified simply because the sky offers nothing in return. The aurora's silence feels intentional, almost sacred. It is a silence that listens, a silence that invites, a silence that humbles. Even though the lights may be rushing upward at incredible speeds, even though electrical currents may be pulsing through the magnetosphere above your head, the world around you remains still. The sky moves. You remain grounded. Between the two lies a space made of quiet, the emotional weight of a silent sky. Humans have always reacted strongly to silent wonders. A waterfall roars, a forest whispers, a storm growls. But the aurora, vast, bright alive, refuses to sound. This inversion triggers something deep. It makes the aurora feel gentle even when it is fierce, intimate even when it spans continents. You look up into motion without noise, power without sound, fire without heat, a storm without thunder. It feels like the sky showing you something personal, something not meant to frighten but to heal, something that belongs more to dream than today. And because it is silent, you lean in, you pay attention, you become part of the quiet. The softest of storms. Tonight, if the aurora appears, whether faint or blazing, listen, not for sound, but for the silence around you. Listen to the way your thoughts slow down. Listen to the way the air feels softer beneath the glow. Listen to the world holding still. And if you feel something, a presence, a whisper, the sense that the sky is speaking without words, you will not be the first. For thousands of years, people have stood where you now stand beneath ribbons of light under silent color and believed that the aurora was alive with voices. Maybe they weren't wrong. Maybe the message of the aurora was never meant to be heard by the ear. Maybe it is a message for the quiet in us, a storm without sound, a sky speaking in light, a silence that feels like awe. Most nights the aurora keeps its silence. It drapes itself across the sky like a great river of light flowing without a single audible breath. The world below remains still. Frost settles, ice hardens. The cold air hangs heavy without vibration. But on rare nights, when the sun has sent a particularly fierce pulse of energy, people claim something different happens. They say the sky whispers, a faint crackle, a soft hiss, a brittle snap like static brushing against hair, voices from the light. These reports are scattered across centuries and cultures. A lone hunter on a frozen lake, a scientist monitoring instruments on the tundra, a group of travelers who swear the air popped as green fire raced overhead. And though most auroras are completely silent, the whispers return often enough to linger in collective memory. For generations, such stories lived only in folklore, nothing more, until modern science began to wonder, what if the sky truly does speak in its own quiet way? The first listeners. Long before laboratories, Arctic peoples treated these faint sounds as part of the aurora's spirit. Inuit hunters spoke of soft rustling noises that accompanied the brightest displays like fabric brushing against itself in a slow dance. Sami elders warned children not to clap or whistle beneath the lights, for the aurora might answer, not with a boom or a roar, but with a delicate electric shiver. In some parts of Alaska, old stories describe the lights as singing snow, a whisper heard only on the coldest nights when the air is so still it feels sharp to breathe. Nobody knew what caused these sounds, but the idea persisted when the aurora is strong enough the air might remember to speak. Science meets the whisper. For decades, scientists dismissed the idea. The aurora is far too high, 80 to 200 kilometers above Earth. Sound cannot possibly travel that distance. The upper atmosphere is too thin. The physics is unforgiving. But the witnesses kept coming. Researchers, pilots, station crews, people trained not to imagine things. Then a strange experiment changed everything. Finnish researchers placed sensitive microphones near frozen lakes and recorded during major geomagnetic storms. What they captured were faint pops and clicks occurring at the exact same moments that all sky cameras showed sudden brightening in the aurora above. Not delayed, not imagined, synchronized. The sounds were happening at ground level, not traveling from space but forming here in the cold air just a few meters above the Earth. Something real was happening. The electric air. The leading theory is as strange as it is beautiful. During major auroral storms, the magnetic field above Earth vibrates and shifts. These changes can charge layers of air near the surface, especially on calm, cold nights, when the atmosphere becomes stratified, splitting into sharp layers of temperature and humidity. In those conditions, a charge can build silently. Building, until the magnetic disturbance triggers a sudden discharge. A spark too small to see but large enough to create a faint sound. A tiny snap of electricity. A whisper of the sky. This would explain why the sounds are heard only during intense auroras and only in specific weather. Clear, cold, unusually still nights conditions where the lower atmosphere becomes a natural resonating chamber for electrical imbalance. To the ear, the effect feels uncanny, as if the aurora itself were making noise. In truth, it is the Earth responding. The lights above move, and the air below answers. Static snow and magnetic breath. Some researchers compare the effect to static electricity jumping between fabrics. Others describe it as the sound of thin ice fracturing gently. A few recordings resemble the soft crackle of a distant campfire, random, uneven yet unmistakably real. There is no single tone, no single rhythm, only the briefest whisper born of charged air finding balance. The aurora shakes the magnetosphere. The magnetosphere shakes the atmosphere. The atmosphere releases a tiny breath of sound. It is a chain reaching from the sun itself to the air inches above your head. The most intense nights. The whispers seem most common during extreme geomagnetic storms events like the Halloween storms of 2003, or the great storms of the 1980s when the aurora surged far from the poles and the sky glowed red and green even above cities like Rome and Tokyo. People who were there still talk about it. The air felt charged. I swear I heard a crackle, but nothing moved. It was like the sound came from nowhere and everywhere at once. Imagine standing outside on such a night. A green arc stretches across the sky like a gate. Red streamers descend like silent rain. Purple flames flicker along the edges. The brightness lifts shadows from the snow. Your breath rises in slow clouds. And in the stillness, pop a tiny spark of sound, as if the sky had cleared its throat. You look up, and the aurora races across the night like a river of fire, the edge between science and wonder. Even now, the phenomenon remains mysterious. Scientists agree the sounds are real. But the mechanism, the conditions, the exact physics, those parts are still unfolding. Some theories propose coronas of electric charge forming around human bodies, or clothing during extreme events. Others suggest the Earth's magnetic field may briefly interact with metal objects, glasses frames, zippers, tripod legs creating tiny vibrations. None of these explanations are complete. All capture pieces of the truth, but the whole picture remains half in shadow, and perhaps that is exactly as it should be. For even when science explains the whisper, it does not diminish it. If anything, it deepens the mystery, the aurora's ability to reach into our world not only with light, but with touch, soft, electric, fleeting. Listening for the sky. If you ever find yourself beneath an intense auroral storm, truly intense, the kind that turns the landscape green and paints the clouds crimson, pause. Stand still. Let the cold air settle around you. Listen. Not for thunder, but for the smallest breath. A spark, a crackle, a whisper so light it might be your imagination. But if you hear it, you will join a lineage thousands of years old people who have listened to the voice of the sky, not loud, not clear, but unmistakably real. True or not imagined or measured myth or physics, the whisper of the aurora reminds us of something profound. Even the quietest phenomena can hold entire worlds of meaning. Even the faintest sound can connect Earth to its star. And sometimes, On the coldest nights, the universe speaks in a voice no louder than a spark. Most people imagine the aurora as a gift reserved for the far north and far south, a polar phenomenon rooted in cold air and long winter nights. A light that belongs to snowfields, tundra, and frozen oceans. A companion of silence and ice. It is easy to forget that the aurora is not bound to those lands, it merely chooses them first. But the sun has moods, rare, powerful moods, and when a truly enormous solar storm strikes Earth, the auroral ovals swell far beyond their usual borders. They break free of the Arctic and Antarctic circles. They expand across continents, reach into unfamiliar skies, and descend into latitudes that never expect them. On those nights, the aurora travels. On those nights, the sky glows where it has no right to glow. On those nights, the aurora reaches the equator. The nights the tropics turned red. History holds scattered records of these impossible events. They read like stories of omens, miracles, or catastrophes, because to the people who witnessed them, those lights were all of these things at once. In ancient China, scribes described red vapors filling the sky from horizon to horizon. They wrote of nights so bright that travelers could read letters on silk. They wrote of shimmering banners that looked like the sky catching fire. These were auroras seen far south of their usual home. In the Mediterranean world, Roman historians once recorded a night of blood when the sky turned crimson from end to end. Farmers thought distant cities were burning. Soldiers believed the gods had set the heavens aflame. No one imagined the cause lay beyond Earth in storms on the sun itself. Medieval Japan documented a night when red clouds writhed like snakes filling the sky over Kyoto. Courtiers interpreted it as a celestial warning. Poets wrote that the sky glowed like a sunset that refused to end. In tropical Mexico, Maya records describe a night when the sky burned with luminous beams reaching upward, like the roots of a great cosmic tree. Priests saw it as a message. Farmers saw it as a threat. Children perhaps saw it as beauty. Even further south in Colombia and Ecuador, early colonial accounts describe strange red arches glowing over the mountains, lights so unfamiliar that witnesses compared it to distant volcanic eruptions. These were not myths. These were auroras, giant ones, born of superstorms that pushed the auroral oval all the way to the equator. Why the impossible happens. Normally, the aurora hugs the poles because Earth's magnetic field channels solar particles along its curved field lines, funneling them into two oval-shaped regions at high latitude. But in the rarest, strongest geomagnetic storms, the magnetosphere distorts. The oval swells, the boundaries of auroral activity expand. What is usually confined to Alaska, northern Canada, Scandinavia, and Siberia begins to push farther and farther outward. A moderate storm brings auroras to Scotland. A strong storm brings them to France. A very strong storm touches Italy or Texas. A truly enormous storm, one that happens perhaps once in several centuries, pushes auroras across the entire world. On such nights, Earth glows like a lantern. The aurora becomes a planetary event. At the equator, the magnetic field lines run almost horizontally. For an aurora to appear there, the storm must be unimaginably powerful. The sun must send a coronal mass ejection so dense, so fast, and so magnetically aligned that Earth's magnetic shield is compressed like a drumhead struck with force. The aurora breaks free of its boundaries. It pours down magnetic field lines never meant to carry it. It shakes the sky in places where people have never heard its name. How it looked to ancient eyes. Imagine standing in a warm tropical night air, soft crickets chirping the smell of Earth, and plants rising from the dark when suddenly a red glow blooms across the entire sky. No cold wind, no northern horizon, no familiar landscape of snow, just heat, and a world turning crimson above you. To ancient observers, this was not a display of science. It was a revelation, an event so far outside normal experience that it demanded interpretation. Some believed the heavens were burning. Some believed warriors marched across the sky. Some believed spirits were traveling between worlds. Some believed gods were angry. And yet mixed with fear, there was awe. Because even in the tropics, light this strange could only feel supernatural. A farmer in ancient Vietnam might have looked up from his field and seen a blood-red arc rising like a second dawn. A sailor crossing the Indian Ocean might have watched vertical beams shimmer like ghostly pillars above the water. A villager in the Philippines might have seen the night sky ripple like fabric held up to the wind. None of them knew the word aurora. All of them felt its power. the emotional shock of light. Out of place. There is a special kind of awe that comes from encountering something beautiful where it does not belong. A snowflake in the desert, a rainbow at night, a glowing circle in a place where no such glow should be. When auroras reach the equator, the world witnesses one of nature's rarest inversions, the northernmost of lights appearing in the southernmost of climates. The cold sky descending into warmth. People stand outside in short sleeves, barefoot on warm stones, surrounded by palms and monsoon rain, and watch the polar sky come to them. Their shock echoes across time. A Chinese scholar once wrote, "The sky dripped red silk upon the world and we had no words for it." A medieval monk in Central Europe wrote, "It was as if night became a wounded day." Indigenous historians in the Amazon later described a night when the great serpent of the heavens shed its skin across the sky. Fear and wonder intertwined, the modern return of ancient light. Today scientists can explain why these events happen. They can model changes in the magnetosphere. They can chart the swelling auroral oval. They can predict which low-latitude regions might see the glow. But even now, when a severe geomagnetic storm pushes auroras toward the tropics, modern observers feel the same shock ancient witnesses did. Social media fills with disbelief. People gather in parking lots and beaches. Lights appear over rice fields, deserts, rainforests, and cities lined with neon. Children point. Adults forget to speak. Because no matter how well we understand the science, the sight of an aurora in a warm climate feels like a crack in reality, a reminder that our planet is small, the sun is powerful, and the sky still holds surprises. A world connected by light. When the aurora reaches the equator, it becomes the great unifier. For a brief night, the entire planet shares the same glow, from Arctic ice to tropical coastlines, from snow to jungle, from deserts to mountains. People separated by oceans look up at the same impossible light. And in that moment, the world feels gently, quietly connected, not by fear, not by myth, but by awe. Because even the rarest storms carry beauty. Even the most powerful events bring wonder. Even the sun in its moments of greatest force gives us something we can only describe as a gift. The sky glows where it does not belong, and for one night the whole earth lifts its face to the lights. Most auroras glow in shades of green soft curtains, drifting waves the colour of oxygen breathing in the middle sky. But every so often the night turns red. Not pink or purple, not a blush at the edge of green, but a deep burning crimson that floods the heavens like fire. These red auroras are the rarest and most haunting of all. They glow higher than any other auroral light, as high as 350 kilometers above Earth, where the air is thin as stardust and movement feels like slow, silent memory. Because they appear so high, their glow spreads wide. Because they glow so wide, they paint entire horizons. And because they glow so red, humans throughout history have mistaken them for one terrifying thing: fire in the sky. A world that looked like it was burning. Imagine living before electricity, before satellites, before science offered explanations. You look to the north or to the south and see a red glow pulsing like a distant wildfire. It brightens, it spreads, it climbs, it looks alive. Villagers rush out of their homes pointing. Fishermen leave the docks watching the horizon. Travellers halt their caravans, unsure if something enormous is burning just out of sight. But the glow does not fade. It does not flicker like normal flame. It rises into the sky steady and unreal, a whole hemisphere tinted the colour of blood. Is it a city on fire, a mountain, a forest? No one can tell. The sky itself burns. Mythology is born from red light. Because red auroras are rare, they were never normal. Every culture interpreted them as a message, a sign, a warning, a story written in colour. Across the world, red auroras became woven into myth. China, the dragon's breath. Ancient Chinese astronomers described blood vapours and crimson clouds rising from the northern horizon. They wrote that it resembled the breath of a celestial dragon, an omen of turbulence in the empire. Dynasties recorded these events as signs of change, rebellion, or the displeasure of heaven. A sky turning red meant something immense was about to unfold. Japan. The dancing ghosts. Heian-era records describe nights when the sky glowed red, as if demons marched across the heavens. Court nobles believed these lights were a curio, wandering spirits illuminated by the gods. Poets wrote that the red sky was the road of the dead, lit for travellers between worlds. The glow was not fire, but the reflection of spirits. Europe, the fire above the clouds. Medieval Europe feared red auroras with particular intensity. Chronicles describe the sky glowing like a great fire, prompting villagers to ring church bells and pray. In some regions, people believed the red aurora was the glow of cities burning far away, an omen of battles yet to come. In 1561, a red aurora over Prague was interpreted as a celestial battle, a sign of war, famine, or divine judgment. Broadsheets illustrated it as flaming swords and shields in the sky, the colour of war, the colour of plague, the colour of prophecy. Indigenous North America, the spirit path. Certain First Nations, especially in the Canadian plains, saw red auroras as the pathway of spirits ascending to the next world. The brighter the red, the more souls were believed to be travelling. Some tribes stayed indoors to show respect, others watched in silence as the heavens opened. The Maori of New Zealand, fire of the ancestors. In Aotearoa, the red southern lights, Tahunuia Rangi, the great burning sky, were believed to be the campfires of ancestors glowing beyond the horizon. A red aurora was a night when the spirits drew close, lighting the darkness with memories of those who came before. What makes the sky turn red? Scientifically, red auroras arise from high-altitude oxygen atoms releasing energy, slowly far above the green layers where oxygen glows at 100 kilometers. At these higher altitudes, the air is so thin that excited atoms can hold onto their energy for seconds before releasing it as deep scarlet light. Because the emission is slow and diffused, red auroras spread across immense areas, giving the impression of a vast, steady glow exactly like a distant fire. To ancient observers, this made perfect sense. The heavens were burning. But the truth was quieter than fire and more beautiful. The glow was the Earth breathing space weather energy, painting the sky with the signature of high-altitude oxygen, slow, silent, majestic. Red auroras in the warm world. Red auroras often appear during extreme geomagnetic storms when the auroral oval expands far from its polar boundaries. In low-latitude regions, Italy, Greece, Persia, India, even farther south, the red component is most visible, because the green aurora remains below the horizon. People see not curtains or ribbons, but an entire sky tinted red. In the year 1770, a massive geomagnetic storm drenched East Asia in red light for 9 consecutive nights. Sailors navigating near China wrote that they believed entire coastlines were on fire. Merchants rode through villages that had gathered in fear to wait for the dawn that refused to come. In 1859, during the Carrington event, the sky glowed so red in the Caribbean that ships' crews thought nearby islands were burning. Telegraph operators in Havana ran outside searching for the source of the fire. They found only the sky. Emotion before explanation. Even today, the sight of a red aurora evokes a different emotional response than a green one. Green feels alive, flowing almost playful. Red feels enormous, ancient, mythic, a colour that belongs to worlds older than ours. It carries weight, it carries memory, it carries something beyond explanation. When the sky turns red, people fall silent in a way they do not during green auroras. There is reverence in the air as though the sky is telling a story, one written in the language of fire and old myths. This emotional gravity is universal. A scientist in Iceland stepping out of a laboratory feels it. A child in Alaska watching from a frosted window feels it. A traveller in Chile looking up from a dart road feels it. Red auroras are rare enough to feel like omens even now. Not omens of disaster, but of magnitude, reminders that Earth is connected to a star, and that the universe can astonish us in colours meant for stories as much as for science. A glow that echoes across time to night. If a crimson glow appears on the horizon, remember this. You are seeing the same light that terrified emperors, inspired poets, guided priests, and moved entire civilizations to write legends. You are standing where ancient watchers once stood, feeling the same awe they felt, that mixture of fear, beauty, and reverence that only a red aurora can bring. A glow mistaken as fire, a signal interpreted as prophecy, a colour that binds the past and present in one long, quiet breath of cosmic light. The aurora carries many colours, many shapes, many mysteries, but it also carries many names, each one a window into the world of the people who watched the sky long before science ever traced its cause. To say aurora is to speak in the tongue of ancient Rome. To say Govsahas is to speak in the language of the Sami, the indigenous people of northern Fennoscandia. Both names describe the same light, but each reveals a different way of understanding the sky. Aurora, the Roman dawn. The word aurora comes from Latin. It means dawn, not just the morning light, but the goddess of daybreak herself. Aurora, sister of the sun and moon, was said to sweep across the sky in robes of colour announcing the arrival of sunlight. When early scholars in medieval Europe saw the shimmering lights to the north, they borrowed her name, a sky that glowed red and gold in the night, a horizon that burned like morning long after sunset. What else could it be but dawn visiting at the wrong hour? Even today the name feels fitting. There is something dawn-like in the aurora's gentle arrival. Its edges brighten the horizon. Its glow stretches like the first light touching the clouds. Its movement feels like a world waking. But the name Aurora is also a reminder of distance of people far from the Arctic, imagining the lights in the language of southern skies of sunlight and warm horizons. It captures the beauty, yes, but not the lived relationship that northern cultures built over thousands of years. For that, we must look to a different name, a northern name, a word shaped by people who grew up inside the light. Gwavsahas, the light you can hear. In Sami languages, the aurora is often called Gwavsahas, pronounced roughly Govsahas. It is a word that resists simple translation. Most often it is described as the light you can hear. This does not imply literal sound, not always, not for everyone, but a sensation, a presence, a feeling that the aurora is more than light. A phenomenon that touches not just the eyes, but the imagination, the skin, the breath, the world around you. For the Sami, Gwavsahas is not merely a visual event, it is alive, it is aware, it is something to approach with respect. The Sami worldview is deeply interconnected. Land, sky animals, spirits and ancestors, all woven into a single fabric. The aurora is part of that fabric. It belongs to the sphere of things that are powerful, but gentle, beautiful, but unpredictable. A light that watches. Back. Traditional Sami teachings often warn children not to whistle or sing loudly under the aurora. The belief is not fear exactly, but reverence. The lights notice. The lights listen. In some regions, the aurora is described as a force that could reach down and take those who mocked or disrespected it. Not a punishment, but a reminder of harmony, the same way one does not shout at sacred lakes or disturb resting animals. Silence was a form of greeting. Stillness was a form of respect. Looking up was a way of acknowledging companionship. And in return, the aurora offered something more than sight. It offered presence, a quiet, shimmering sense of being enveloped by light that seemed to pulse with breath. A bridge between worlds. In many Sami stories, Gwavsahas appears in moments when the boundaries between the human world and the spirit world grow thin. The glow becomes a kind of bridge, an atmospheric path linking the living and the unseen. Some narratives describe the lights as the energy of departed souls. Others call them the reflections of great herds moving across the sky, their hooves striking sparks. Still others speak of them as the glow of rivers or fires in the spirit realm. None of these stories seek to explain the aurora as science explains it. They describe its meaning, not its mechanism. They place the light in a tapestry of relationships, not in isolation. In this worldview, the aurora is not a spectacle, it is kin, a universe full of names. Other Arctic peoples also gave the aurora names that reveal their emotional relationship to the sky. The Inuit of Nunavut called the lights Aksanet, the ones that play ball imagining spirits tossing a glowing object across the sky. The Cree called the northern lights the dance of the spirits. The Sami in different regions used words related to flame flow or circle, describing movement rather than colour. In Greenland, some describe the aurora as the sky breathing. Each name tells a story about the observer. Each name is a form of cosmology. Each name carries a worldview. To the Romans, the aurora was dawn misplaced. To the Sami, Gwavsahas was a presence that listened. To the Inuit, the lights were playful. To the Norse, they were the armour of warrior maidens flashing in the heavens. Different languages, different mythologies, different climates, yet all sensed something greater than themselves in the glow. The cultural light we carry forward. Today, we understand the aurora, scientifically solar wind magnetic fields, charged particles striking oxygen and nitrogen atoms, but the names endure and with them the meaning. Aurora reminds us of beauty, of dawn renewal, and the gentle arrival of light. Gwavsahas reminds us of relationship of respect, humility, and the idea that nature is not separate from us, but interwoven with our lives. These names coexist not as contradictions but as companions. One belongs to mythic Rome, warm in the Mediterranean sun. The other belongs to the far north, whispered into existence by generations who walked the tundra and watched the lights from reindeer camps under winter skies. Together they offer a full picture: the aurora as light, the aurora as story, the aurora as presence. A sky with many voices. When you stand beneath the aurora, you're standing inside thousands of years of human feeling. You're sharing the same light that inspired mythologies, guided migrations, and shaped entire cosmologies. You are part of a lineage of watchers, people who looked up and wondered what they were seeing, and who gave the phenomenon a name, because naming is a way of forming connection. Tonight, if the lights appear, let their names accompany you, Aurora. Gwrvshas, Aksanit, Revontulet, Spirit Fire, Dawn of the Night, each name a different voice of the north, each name a way of saying, the sky is alive, and so are we. High above Earth, far above mountains, clouds and weather, the atmosphere becomes a quiet cathedral of atoms. Thin, cold, still. Up there, the air is no longer a single substance. It becomes layered like a series of invisible floors in a vast cosmic tower. And when solar particles arrive from the sun and collide with these layers, each altitude responds with its own color. The aurora is not one light. It is many lights stacked in height, in chemistry and behavior. If the night sky were a canvas, the aurora would be the brushwork of atoms, each one releasing its own signature color. This is the atomic rainbow of the upper sky. A tower made of air. To understand the aurora's colors, imagine the atmosphere as a tall building miles and miles high, with each floor made of different conditions. Lower floors, thicker air, more pressure, more collisions. Middle floors, thinner air atoms spaced out like lanterns in a dark field. Upper floors, almost space where a single atom waits seconds before meeting another. Each floor responds to energy differently: green, red, blue, purple. These are not random. They emerge from very specific heights, where the atoms of oxygen or nitrogen behave like tuned instruments waiting for the right note. The green level, Earth's middle sky. 100 kilometers, most auroras glow green. Why? Because at around 100 kilometers, where the air is thin but not too thin, oxygen atoms become excited by incoming electrons. When these atoms calm down, they release a photon of pure green. Think of it like this. If oxygen were a musician, 100 kilometers is where it plays its favorite note. There is just enough room for atoms to hold their excited state, but enough pressure that they don't wait too long to release it. This region is Earth's brightest auroral floor. People often feel instinctively drawn to this light, partly because human eyes are most sensitive to green, but partly because this middle layer is so active and lively that it feels like the aurora's natural heartbeat. The red level, the edge of space, 200-350 kilometers, far above the green glow oxygen, plays a different note. At extreme altitudes, the air is so thin that atoms can hold onto energy for seconds before releasing it. And when they finally do the photon they emit is red, deep, diffuse, haunting. This is the red veil, the slow-motion aurora. Imagine striking a bell in normal air and hearing a chime. Now imagine striking a bell in near vacuum, so quiet, so still, that the bell rings slowly, almost mournfully. That is red oxygen. It glows softly, widely, and often unexpectedly. To observers far from the poles, this red glow is sometimes all they see: a blood-red horizon that looks like distant fire. A single atom at this altitude can shine red all by itself like a solitary lantern suspended in space. The blue and purple level. The lower sky, 90 kilometers below the green layer, lies another world, a region where nitrogen molecules dominate. Nitrogen does not glow like oxygen. It flashes, it sparks, it releases energy in tight, rapid bursts. Blue and purple auroras come from this lower band, a layer where energetic particles collide with nitrogen and produce quick electric colors. Picture a cold sparkler glowing in winter air. That is nitrogen's light. Blue is the color of ionized nitrogen. Purple is the color of neutral nitrogen, releasing energy just above the boundary of human vision. These flashes are fast, so fast that human eyes often miss them. A camera patient as always sees what we cannot. It gathers the scattered violet photons until a shimmering edge appears, a delicate border at the bottom of a green curtain. Why each color lives where it does, atoms at different heights live different lives. At low altitude, the air is dense. Collisions happen constantly. Atoms excited by the aurora barely have time to glow before another collision interrupts them. Blue and purple fast colours can survive here. Green, which needs a bit more time, thrives slightly higher. It's like a note that needs a quiet room to resonate. Red, which needs a long, peaceful pause before releasing its energy, can only survive in the highest levels, where an atom floats alone, waiting in silence. If the aurora were a choir, red would be the long, slow note held by a single soprano in the distance. Green would be the steady melody in the middle of the hall. Blue and purple would be the quick, bright harmonies dancing near the foot of the stage. Together they create a vertical symphony. How the sky mixes its colours. The aurora doesn't paint in strict bands. Storms blend the colours, green spills upward into red. Purple edges appear beneath green arcs. Blue ghost lights flash near the lower boundary. During strong storms, entire regions of sky shimmer with mixed hues, like layers of watercolour meeting and merging. But each colour still remembers its home altitude. It is the chemistry of height that decides the palette, an intuitive way to see the sky. Imagine the atmosphere as a glass sculpture, tall, fragile, layered with colour. Now imagine shining a beam of energy from the sun through it. Where the sculpture is thick, the light sparks blue. Where it thins, it glows green. Where it becomes almost transparent, it turns red. The aurora is not painted onto the sky, it is drawn through it. Why the colours feel emotional. The atomic rainbow has a surprising emotional logic. Green feels alive and close. It's literally closest to us. Purple feels electric and quick. It flickers at the edges where nitrogen dances. Red feels solemn and mythic. It belongs to the uppermost sky, slow and quiet. We respond not only to colour but to altitude, to the sense that some lights are near and some drift far above in the borderland of space. When the aurora blends all these colours at once, it becomes a vertical tapestry, a rainbow stretched not across the horizon, but upward, layer by layer into the night. A sky that reveals its structure through colour. Tonight, if the aurora appears, try to see the sky not as a flat dome but as a tower, a layered cathedral rising above you. Green at your doorstep, purple brushing the treetops, red drifting somewhere near the stars. Every colour is a chemical truth. Every glow is an altitude speaking. This is the atomic rainbow of the upper sky, a quiet spectrum carved into height. A vertical watercolour painted by atoms, a reminder that even the invisible layers of our atmosphere have their own voices, their own personalities, their own light. To the eye, an aurora looks fluid, a single river of light gliding across the sky in long, graceful curves. The green arcs ripple like silk. The red veils drift like slow smoke. The blue and purple edges flicker like breath along the horizon. The whole phenomenon seems smooth, continuous, alive. But in truth, nothing about the aurora is continuous. It is not a river. It is not a sheet. It is not a curtain. It is millions, billions of tiny flashes. Each speck of auroral light is born from a single atom colliding with a single charged particle. That atom glows for a brief moment, a tiny quiet pulse, then falls dark. And yet millions of these pulses across the sky, happening in overlapping waves, create the illusion of a single moving shape. Like raindrops creating a waterfall, like sparks creating a flame, like pixels creating an image. The aurora is not one light. It is countless lights taking turns, the millisecond life of an excited atom. When an electron from space slams into an oxygen or nitrogen atom, it triggers a momentary transformation. An atom pushed into an excited state holding energy. It did not have a heartbeat before. The atom cannot hold that energy for long. Nitrogen molecule might glow for 1,000th of a second. Ionized nitrogen even faster microseconds. Green oxygen, 100 kilonus, a rare exception, lasting up to 3/4 of a second but never longer. Imagine billions of atoms performing these microflares at different times. The sky becomes a vast field of blinking lanterns. But because there are so many flashing in patterns shaped by the magnetosphere, their collective light blends into waves and curtains. Human vision smooths it the way the eye smooths the flicker of a candle flame or the rapid refresh of a screen. We see continuity, but the sky is strobing. The flicker you never notice. Hold your hand very still. Now try to lift it fast enough to see individual atoms glow. You will never succeed. Your eyes cannot resolve milliseconds. Your brain refuses to break the world into flashes. Evolution gave us fluidity where physics gives us pulses. So you watch auroras the way you watch lightning bugs on a summer night, not as separate lights, but as a pattern, a rhythm, a form. The aurora feels alive because billions of pulses overlap so tightly that they become a single breathing organism. High-speed cameras. Seeing the unseeable scientists sometimes point high-speed cameras at the aurora precise instruments capable of filming thousands of frames per second. Through these lenses, the illusion falls away. The green curtain becomes a frenzy of twinkling points. The purple fringe becomes a race of microscopic sparks. Instead of one wave rolling across the sky, the camera sees a swarm of individual fireflies, each one appearing glowing, fading, replaced instantly by others. In real time, these flashes are synchronized by magnetic field lines. They rise and fall like crowds cheering in a stadium, creating enormous arcs of brightness. But frame by frame, the camera reveals that the cheering is never uniform. It is made of countless small voices. The aurora is a mosaic, a patchwork of light stitched together in time. The wave that isn't a wave. When people see a bright ripple, a bright green front racing suddenly upward, they often imagine the entire auroral curtain rising as one structure. But the curtain itself is not moving. What moves is the zone of precipitation, the place where electrons rain down into the atmosphere. That region slides along the magnetic field lines, triggering new flashes as it goes. It is like dragging your hand across long grass. The grass does not travel with your hand, but the motion seems to sweep across the field. In the same way, a wave of brightness is electrons changing location. The green shape is atoms flashing in sequence. The ripple is movement of energy, not movement of matter. The aurora is choreography, not cloth. The subtle jitter. Hidden in the glow, high-speed instruments show something else you never noticed: the aurora jitters. Not by meters, by kilometers. Tiny instabilities in the magnetosphere cause precipitation zones to wobble. A smooth arc becomes a trembling edge, a tight ribbon becomes a vibrating string. You don't see the jitter because the flashes are too fast, too numerous, too forgiving. Your eyes blend their chaos into grace. Just as a candle flame hides its turbulence behind calm edges, the aurora hides its micro-chaos inside a macro smile. A sky made of stardust sparks. If you could stop time and see the aurora at a single frozen instant, the sky would look nothing like a ribbon. It would look like scattered sparks, tiny constellations, a million pinpoints igniting atoms glowing alone in a vast cold emptiness. Space weather is granular. Light is particulate. Beauty is statistical. It is only when time flows again, when those flashes overlap, merge and echo, that the aurora becomes a river. Why the illusion feels alive. Our minds love continuity. We connect dots into lines, blips into motion, flashes into waves. This ability is why we can watch movies, why we see motion instead of still frames, why fire looks like a coherent form rather than chaos. The aurora is the universe performing cinema. Earth's magnetic field is the projector. Atoms are the pixels. Your brain is the interpreter. The sky becomes a seamless flow because billions of atoms agree for a moment to glow in harmony. The emotional truth behind the science. There is something tender in this knowledge that a single wave of aurora, something so soft, so continuous, so elegant, is built from countless tiny efforts. No atom glows for long, no flash survives on its own, but together they create something vast enough to fill the night, a sky made of moments woven into movement, a storm made of sparks woven into silence, a universe made of millisecond miracles woven into awe. A quiet lesson from the lights. Tonight, if you see the aurora ripple across the stars, remember that it is not one wave but many. You are watching the collective glow of countless atoms, each giving the smallest flash of light, each lasting only a breath, each disappearing as others take their place. The wave is the illusion. The truth is the millions of sparks. And yet the illusion is real to us, beautiful to us, meaningful to us. Just like all things in nature built from the smallest pieces but experienced as a whole, auroras are born from storms so vast they begin on the surface of the sun, cross millions of kilometers of space, and arrive at Earth as shimmering curtains of color. We watch them from snowfields, from forests, from city rooftops, and something inside us softens. The lights feel peaceful, delicate, almost healing. But the aurora is only the visible edge of something larger. Behind that beauty lies a storm powerful enough to touch not just the atmosphere, but our technology, our satellites, our communications, our power grids, our electrical lifelines. In the same breath that the sky glows with wonder, it warns, a storm that touches the modern world. The aurora itself is harmless. It is the quiet glow of atoms releasing light. But the magnetic and electrical disturbances that create the aurora, those are not always gentle. When a strong solar eruption strikes Earth, the magnetosphere shudders. Currents surge through the upper atmosphere. Charged particles rain into the poles. Magnetic fields ripple like shaken water. And invisible waves of disturbance reach far beyond what we can see. Tonight's aurora might dance softly above you. But above that, beauty satellites are shaking in invisible winds. Satellites in a rough sky. The space above Earth is not empty. It is filled with the tools of our civilization, GPS constellations, weather satellites, communications networks, Earth-observing sensors, Starlink and broadband fleets, scientific instruments orbiting in fragile balance. During severe geomagnetic storms, the upper atmosphere swells. The air thickens at altitudes where satellites normally glide through thin plasma. Drag increases suddenly, sometimes by 50%, even 100%. It is like flying an airplane into a headwind that was never forecast. In early 2022, a moderate storm caused dozens of newly launched satellites to fall out of orbit before ground control could stabilize them. A single bad solar storm could affect hundreds. Even high above the atmosphere, satellites face danger. Charged particles can disrupt electronics, scramble memory, flip bits in processors, or permanently damage sensitive components. Modern satellites carry shielding, but storms can still reach them. An aurora may paint a sky with peace, while hundreds of kilometers above spacecraft weather an invisible gale. GPS and navigation. A quiet confusion. Auroral activity disturbs radio waves traveling through the ionosphere. GPS signals pass through this region, relying on predictable atmospheric conditions to stay accurate. But during storms, the ionosphere becomes a turbulent sea of electrons. Signals scatter, slow, refract. A farmer's GPS-guided tractor may drift. A pilot's navigation system may jitter. A ship's autopilot may lose precision. Surveyors may find their measurements suddenly unstable. Most disruptions are small meters, not miles. But even a few meters matter in aviation, in agriculture, in search and rescue. The aurora may shimmer quietly, but beneath it guidance systems are whispering uncertainties. Radio voices lost in the glow. High-frequency radio waves bounce off the ionosphere to reach distant receivers. During storms that mirror becomes unreliable, sometimes absorbing signals completely. Amateur radio operators call this a blackout. A pilot flying over the poles calls it a loss of communication. A ship in the Arctic calls it a moment of silence at sea. The aurora glows above a tapestry of color, quietly erasing voices traveling below it. The power grid, Earth's own nervous system. The strongest effects appear not in the sky, but deep underground. When Earth's magnetic field shakes, it induces electric currents in the soil currents that try to climb into the power lines built across continents. Most of the time, the grid absorbs these surges without complaint. But in extreme storms, the currents can overload transformers. They can trip protections. They can cause blackouts. In 1989, a geomagnetic storm shut down the entire power grid of Quebec. In minutes, 6 million people were without electricity. The aurora that night was breathtaking. It stretched as far south as Cuba. But beneath that beauty, an entire region went dark. Modern grids are improved, but they are still vulnerable. Long wires across long distances, perfect antennas for celestial storms, awe and caution in the same sky. And so we learn something important. The aurora is not danger, but it is the visible signature of forces that can be dangerous, a silent warning light, a natural indicator of a space weather storm. The beauty and the risk are two faces of the same event. One touches the sky, the other touches our world. Why this knowledge matters. We are a species that has reached into space. We rely on satellites to guide our planes, measure our crops, send our messages, predict our storms. We rely on long power lines to light our nights, heat our homes and keep our hospitals alive. A storm from the sun can touch all of it. Science does not tell us this to frighten us. Science tells us because awareness is protection. Because monitoring the sun, tracking solar storms and preparing our grids and satellites is how we remain resilient. The aurora is nature's gentle reminder. The space around us is alive, and we must learn to live with its moods. But the beauty remains untouched. Even with all this knowledge, the emotional truth of the aurora does not dim. If anything, it becomes more profound. To know that the same phenomenon capable of stirring satellites and grids can still paint the sky with silence, delicate, flowing, luminous silence, is a reminder of nature's duality. The sun gives warmth and light. It also sends storms. The aurora gives beauty and wonder. It also reveals hidden forces. This balance is not frightening. It is honest. It is the world as it is magnificent, complex, powerful. The calm behind the power. Tonight, if the aurora glows above you, let the awe come first. Let the colours wash across you. Let the quiet fill your breath. Let the lights remind you of the bond between Earth and its star. But somewhere inside that awe, hold a small awareness. This beauty is also the signature of a storm. A peaceful face carved from powerful forces. Beauty and danger woven into a single breath of the sky. Every storm has a beginning. For thunderstorms, it begins with rising air. For hurricanes, with warm oceans. But for auroras and for the dangers that travel with them, the beginning lies 150 million kilometers away on the surface of the sun. The sun does not explode when it sends a warning. It brightens, it crackles, it reshapes its magnetic skin with slow, deliberate violence. And far from the world below, in the emptiness between planets, silent sentinels watch, the quiet watchers of space. Orbiting Earth, stationed at the L1 Lagrange point, drifting between planets, a fleet of satellites keeps endless vigil over the sun. They do not sparkle, they do not roar. They move in silence, solar panels open like wings, listening for changes in the star's breath. Among them, Soho, the veteran sentinel gazing at the sun since 1995. SDO, with eyes so sharp it can see loops of magnetism the size of continents. Ace and Diaskova measuring the solar wind moments before it reaches Earth. Parker Solar Probe diving close to the sun's corona, tasting the fire directly. Stereo watching the sun from opposite sides like two scouts circling a mountain. Together they form a web of awareness, a constellation of guardians, whose entire purpose is to read the sun's intentions. Their instruments sense heat, light, magnetic fields, particle storms, shock waves. They measure the density of the solar wind, the strength of magnetic knots on the sun's surface, the speed of coronal mass ejections racing toward Earth. They are the quiet listeners, the watchers in the dark, Earth's early warning system, the first sign. A flash. When the sun flares, the first signal arrives as light X-rays and ultraviolet radiation traveling at the speed of light. In 8 minutes they reach Earth. Our satellites detect it instantly. A flare means something beneath it has snapped a magnetic tangle, tearing apart in a burst of energy. This first flash cannot be stopped. But it is only the opening note. The true storm, harmful particles and magnetic shock fronts, comes later. The second sign, the arrival of fire. A coronal mass ejection, CME, can take anywhere from 15 hours to 3 days to reach us. And in that time the watchers gather every clue they can. Ace and Diaskova, stationed 1 million miles, sunward of Earth, float like buoys in the stream of solar wind. Their sensors taste the charged particles, measure their speed, read the direction of the magnetic field locked inside them. If the magnetic field is pointed north, the storm slides past us gently. If it is pointed south opposite Earth's magnetic orientation, the two fields interlock like fingers. That is when storms slip into the magnetosphere. That is when auroras brighten. That is when power grids and satellites feel the strain. When his CME sweeps past Ace or Diaskova, we have roughly 20 to 40 minutes before it reaches Earth. 20 to 40 minutes, the space weather equivalent of a tornado siren, a final warning before impact. The forecasters who listen to the sun. On Earth, inside quiet rooms glowing with screened scientists at NASA, NOAA's Space Weather Prediction Center, and agencies across the world remain awake through the night. They read magnetograms like meteorologists read clouds. They watch X-ray flux charts the way sailors watch storm fronts. They track solar wind streams the way pilots follow jet paths. And when the watchers in space send word, a CME, approaching a shockwave forming, they prepare alerts. Airlines reroute polar flights. Satellite operators place spacecraft into safe modes. Power companies adjust grid load. Astronauts shelter in shielded compartments. Radio operators brace for blackout. These preparations unfold quietly and visibly with steady hands. Most people never know any of it happened. They only see the sky glow brighter that night, in a way that is the highest success when caution is invisible, because it has worked. The drama, hidden behind the calm. There is a strange tension in space weather. On the surface everything seems peaceful, a green arc drifting across the sky, silent, serene, breathtaking. But behind that beauty lies a storm chain, magnetic fields snapping on the sun, shockwaves racing through space, charged particles hammering Earth's shield, power grids humming with extra current, satellites riding waves of atmospheric expansion. It is a ballet of cosmic forces, a negotiation between Earth and Sun. The watchers stand at the midpoint of that negotiation, listening, interpreting, translating. When the Sun sends a warning, sometimes the watchers see a flare and know immediately something big is coming. Plasma lifts off the Sun in a long arc. Space telescopes capture the halo expanding outward. Solar wind speed jumps. The magnetic field shifts. A CME is on the way. The world continues its daily rhythm. Cities glow. Planes cross skies. Ships move across oceans, while far above, satellites relay warnings to Earth. Hours later, sometimes days, the shockwave arrives. ACE detects it first. Its sensors spike. Ground stations receive the data. Then, the magnetosphere feels the blow compressed like a shield struck by a hammer. On the ground, compasses twitch. Power grids hum. Radio channels flicker. GPS signals wobble. And in the sky, curtains of light unfold. Beautiful, massive, transient. The visible signature of an invisible warning. The human side of vigilance. Part of the emotional weight of space weather lies in this simple truth. We exist between a star and a planet depending on both. The sun gives us life. But we must also learn to read its moods. Space weather forecasting is young, barely decades old. But it carries the quiet responsibility of protecting a modern world whose technologies stretch into places storms can reach. And like all forms of vigilance, it is both scientific and human. It is the graduate student watching solar wind charts at 3 a.m. It is the engineer adjusting a satellite's orientation. It is the pilot diverting a polar route. It is the power grid operator balancing load across a continent. Quiet guardians all listening to a star. The light. We see the storm, we do not. When you watch an aurora, you see only the gentlest part of the story. The soft glow is the echo of a much larger conversation between Earth's magnetic field and the solar wind. The aurora is the sun speaking in color, but the watchers, those sentinels in space, and the scientists on Earth listen to the deeper message: a flare has erupted, a shock wave is coming, prepare, beauty and risk, light and warning, grace and gravity, all woven together in one quiet cosmic breath. Tonight, if the aurora glows, gaze at it with wonder but also with gratitude, because somewhere far above you machines and people are listening to the sun on your behalf. Every living thing has a rhythm, a breath that rises and falls, a pulse that expands and contracts, a cycle that repeats so steadily it becomes a kind of quiet music. The Earth is no different. Its auroras, those drifting curtains of light that shimmer around the poles, are not random or chaotic. They follow patterns. They swell and shrink. They brighten and fade. They shift across the sky in repeating cycles shaped by the sun, the seasons, and the geometry of Earth's magnetic shield. Seen from above, the auroral ovals behave like two luminous hearts, one in the north, one in the south, beating in response to the solar wind. They glow, they dim, they widen, they narrow, a planetary heartbeat carved in light. The expanding and contracting ovals. If you could rise far above the Earth, drifting silently over the poles, the auroras would no longer look like tall curtains. They would look like halos, two glowing ovals encircling the top and bottom of the planet, and these ovals are always changing shape. When the solar wind is calm, the ovals relax. They shrink inward toward the poles like lungs exhaling. But when a stream of faster solar wind washes over Earth, or when a coronal mass ejection arrives with magnetic force, the ovals push outward. They expand, they swell, they stretch toward lower latitudes. This breathing of the auroral ovals is so regular, so rhythmic, that satellites can measure it like a pulse. As energy flows into the magnetosphere, the ovals brighten and grow. As the energy dissipates, the ovals fade and retreat. A heartbeat in color, a breathing light, magnetic midnight. The moment of deepest pulse. The aurora is brightest not at Earth's clock. Midnight, but at something called magnetic midnight. Magnetic midnight is the moment when Earth's magnetic field lines align most directly with the stream of solar particles flowing behind the planet. It is when Earth is most exposed to the tail of its own magnetosphere, the long magnetic wake stretching into space like the tail of a comet. During magnetic midnight, the magnetotail tightens. Energy builds. Tension grows, and then like a pulse, the field reconnects and releases energy toward the poles. This release triggers what watchers call a substorm, a sudden brightening and unfolding of auroral arcs. The sky erupts in motion. Ribbons race upward. Green lines crackle like veins of light. Red glows bloom high above. Just as the human heart sends blood surging through the body in periodic waves, the magnetosphere sends auroral waves across the sky during magnetic midnight. A pulse in the heavens. The equinox effect. When the heart beats strongest, the aurora has seasons, not seasons of temperature but seasons of geometry. Around the equinoxes, March and September, Earth tilts in such a way that the solar wind couples more effectively with the magnetosphere. The alignment becomes perfect for magnetic reconnection. It is as if Earth turns its face directly into the stream of the sun's breath. During these months, substorms become more frequent. Aurora intensifies. Ovals stretch farther. The planetary heartbeat grows louder. Scientists call this the Russell-McFerrin effect. But to the sky, it feels like something more ancient, a twice-yearly quickening, a seasonal heartbeat. Long before anyone understood magnetism, indigenous peoples across the north noticed this. They knew the lights grew more active during the changing seasons. They sensed the rhythm, felt the pulse even without instruments. The Earth glows brightest when day and night stand in balance. The magnetosphere's pulse cycles auroras are shaped not only by the solar wind but by the magnetosphere's internal clock, a cycle of energy storage and release that repeats every few hours. Growth phase. Solar wind stretches the magnetotail like a drawn bowstring. The auroral oval tightens, dims, and waits. Expansion phase. Magnetic reconnection snaps the tail. Auroral currents surge. The ovals brighten, violently light, pulsing outward. Recovery phase. The system settles. The auroras fade. The ovals relax back toward the poles. Then the cycle begins again. Energy builds. Energy releases. Energy fades. A breath. A heartbeat. A rhythm repeated endlessly in silence. The rhythm you can't hear but can see. Most storms are subtle. A faint green arc drifting along the horizon. A soft haze of colour above the forest. A glow reflected in snow. The pulse is silent, but visible. Watch long enough and you will notice it. A sudden brightening as energy arrives. A ripple racing upward when a substorm begins. A quiet thinning as the system resets. To sit beneath an aurora is to feel the planet's circulation, a kind of cosmic blood moving invisibly through magnetic veins. 2 hemispheres, 1 heart. The Earth has 2 auroral ovals, one in the northern hemisphere, one in the southern. And astonishingly, they pulse together. A substorm in the north is matched by a surge in the south. An expansion in one oval is mirrored by the other. The pulses arrive on both sides of the world at nearly the same moment, 2 breaths perfectly synchronized. Even though the continents and oceans are different, even though the nights come at opposite times of year, the auroras share one magnetic system. They move as one. Twin heartbeats in opposite skies. 2 lights responding to a single star. What the rhythm means. The auroral heartbeat tells a simple truth. Earth is not isolated. It is not silent. It is not still. It is connected to the sun by invisible threads of magnetism. It is powered, moved, shaped by a star whose moods echo across the sky. It is alive with cycles we can see only when night is dark enough and the solar wind is strong enough. Earth breathes. Earth pulses. Earth glows in response to the touch of the sun, and auroras are the colour of that response, a shimmering expression of the rhythm between world and star. If you ever watch the sky long enough, you might feel it. The dimming, the brightening, the expansion, the release, a quiet luminous heartbeat unfolding above you, not random, not chaotic, not decorative, but rhythmic, cyclical, alive. Auroras are the pulse of the magnetosphere, the breath of the planet, the heartbeat of the Earth made visible. A reminder that even in darkness, our world is always in motion, always responding to the sun, always glowing in time with a cosmic rhythm older than life itself. Auroras feel gentle from the ground, soft ribbons drifting through cold air quiet enough to hear your own breath. But behind that silence lies a level of energy so immense, so fierce, that the atmosphere itself rises in temperature. The upper sky, normally colder than any winter on Earth, can heat by hundreds of degrees in minutes. This is the paradox of the aurora, the softest light born from the most violent forces, the thermosphere. A furnace, above the frost. High above our world, between 90 and 500 kilometers, lies the thermosphere, a realm so thin that you could stand in it and never feel the air against your skin. Yet during an intense auroral storm, this near vacuum becomes a furnace. Electric currents driven by the solar wind dump colossal amounts of energy into this region. Oxygen and nitrogen atoms collide, vibrate, and release heat. Temperatures can jump from 100 degrees to beyond 500 degrees in the span of a storm. To humans, such heat is meaningless. We would freeze instantly in the thin air. But to the atmosphere, the heating is profound. The thermosphere swells. It expands outward like a balloon warmed by an invisible flame. Satellites suddenly find themselves lower because the atmosphere has puffed upward to meet them. The drag increases. Orbits wobble. Engineers watch with careful eyes. A space fire is burning silent cold to the touch, yet immensely powerful. The gigawatt storm's auroras are not powered by small currents or modest forces. They run on gigawatts, billions of watts of electricity. During a major geomagnetic storm, the energy flowing into the upper atmosphere can reach 10 gigawatts, 100 gigawatts, in extreme cases over 1 trillion watts a terawatt. To compare, a gigawatt can power 1 million homes, 100 gigawatts could light an entire continent. A terawatt is enough to run every city on Earth all at once, and yet the aurora uses this power to paint the sky in soft drifting veils. The lights feel ethereal because they are spread across thousands of kilometers of atmosphere. The energy disperses like a whisper across the sky, bright but not overwhelming to the eye. How bright can the auroras become? Most auroras glow faintly enough that long exposure photos make them seem brighter than they appear to the eye. But during extreme storms, the aurora can become brighter than the moon. Imagine standing in winter darkness, snow crunching under your boots, and seeing the entire landscape lit in green and red without a single lamp. Shadows appear, trees glow, ice glitters like polished glass. Historical accounts describe nights when people could read letters by the auroral light. Sailors recorded the sea shining green as though lit from below. Entire towns reported crimson skies so bright that residents believed buildings must be burning. A silent fire lighting the earth. The sky fire that moves like water. The aurora's brightness is not its only intensity. It also carries power through electrojet's vast currents of electricity flowing around the poles. These currents can reach millions of amperes, circling Earth like luminous rivers of electrical force. If you could see the electric currents directly, the aurora would look like glowing lightning frozen into arcs, electric tides carving the night. Yet all we see is the quiet glow. The fire that moves like water, the electricity that behaves like silk. Energy, compared to our cities. To understand the scale of this space fire, consider a large city might use 5 gigawatts at night. A major metropolitan region might use 10-15 gigawatts. The entire auroral oval can consume 100 gigawatts or more during a storm. A superstorm like those seen in 1859 or 1921 can reach 1,000 gigawatts, equivalent to all the electrical generation of humanity today. Every auroral curtain, every flicker, every wave is powered by currents that could run every light, every home, every factory, and every train system across the globe. And it all happens whisper quiet in a sky too cold to touch. Heat without warmth. The thermosphere warms dramatically during auroras, but the heat never reaches down to us. Why? Because there are not enough molecules at high altitude to carry warmth downward. The thermosphere is like a nearly empty room. You can heat it to scorching temperatures and still freeze. The aurora burns from the top down, but it never melts a single snowflake on Earth. It is a fire that warms no one, yet its impact shapes satellites, radio waves, and the entire upper atmosphere, storms that reshape space. Itself, during extreme auroral events, the entire magnetic bubble around Earth, the magnetosphere, contracts and quivers under the pressure of the solar wind. The boundaries shift, the currents surge, the footprint of the magnetosphere deepens into the poles. Earth's magnetic shield absorbs the blow, and the aurora is the visible sign of that impact. It is not simply light, it is Earth defending itself, a billion-watt dance marking every strike, awe and respect in equal measure. When you stand beneath a bright aurora, what you see is only the softest fraction of the storm. You see the shimmer, the drift, the colour, the movement, the gentle glow. What you do not see the 100-gigawatt currents, the superheated thermosphere, the magnetosphere flexing like the ribs of an invisible shield, the electric tides rushing above Earth's poles, the trillion-watt extremes of a superstorm. From the ground, it feels like magic. From space, it looks like energy sculpted into colour. From physics, it is a planetary-scale power surge woven into a painting. Beauty and force, light and electricity, silence and storm, the fire that belongs to space. There is a kind of humility in understanding these extremes. The aurora is not delicate at all, it only appears so. It is a fire the wind cannot move, a storm that makes no thunder, a heat that cannot warm your hands, a space fire, glowing, whispering, immense. Tonight, if the aurora rises bright enough to cast shadows, remember the power behind it. The heat you cannot feel, the electricity you cannot touch, the energy you cannot fathom. A soft light powered by a star. From the ground, the aurora looks like pure silence colour, without sound, motion, without voice. Yet high above the frozen darkness, the sky is anything but silent. Every flicker, every ripple, every drifting curtain of green carries with it an invisible song. Not a song made of air or vibration, but of radio waves, waves that pass through vacuum, through darkness, through the cold geometry of space. Waves that spacecraft can hear even though human ears never will. The aurora is not only a painting of light, it is a broadcast of a world speaking in electricity. The sky that sings in frequencies. Whenever charged particles spiral down Earth's magnetic field lines, they move with a strange grace, swirling like dancers following invisible rails. As they twist and accelerate, they generate electromagnetic waves, radio emissions that echo through the magnetosphere. These waves carry information about the strength of the storm, the bending of magnetic fields, the speed of electrons racing earthward. Scientists call this radiation auroral kilometric emission, or AKE. Unlike visible light, it never reaches the ground. Earth's ionosphere blocks it, holding the sound in the upper sky like a secret. But spacecraft drifting in orbit and probes passing millions of kilometers away have recorded the broadcast, and when those radio waves are converted into sound, the result is haunting. Whistles, chirps, pulses, rising tones that tremble like a bow sliding across a glass harp. Soft hisses that sound like frozen wind brushing across metal. To hear it played back is to realize the aurora is alive with voices, electric whispers in the dark. Imagine standing under a green curtain unfolding across the winter sky. You feel the cold. You hear the crunch of snow. You see the slow pulse of light drifting across the horizon. But above you, in the place where space meets air, the electrons responsible for that glow are singing. They whistle as they spiral. They hiss as they accelerate. They hum with frequencies too low for us to hear. It is the same way the deep ocean sings in pressures humans cannot feel. The aurora sings in frequencies humans cannot perceive. The silence we experience is not absence. It is distance, a gap between our senses and the universe. Probes. Listening from the void. In 1977, NASA launched Voyager 1 and Voyager 2 spacecraft built to explore the outer planets. Neither mission was designed to study Earth's aurora, yet both heard it on the way out. As the probes drifted beyond the orbit of the Moon, their instruments picked up faint rhythmic pulses coming from our planet, a soft chorus emitted by particles spiraling along magnetic lines. Earth was singing in radio waves. Later missions, Cluster Themis. Cassini confirmed the same thing: the aurora is one of the loudest radio sources in the solar system. Even from millions of kilometers away, spacecraft can detect Earth's whispered harmonies. When translated into sound, the signal becomes something eerie and beautiful: rising chimes, digital crackles, liquid tones sliding past each other, sudden bursts that sound like cosmic raindrops striking a metal roof. It is the sound of a magnetic world exhaling electricity. The brushes behind the painting. If the aurora is a painting made of light, then radio waves are the brushes revealing its motion. Every flicker corresponds to a change in current. Every brightening marks a burst of electrons plunging downward. Every ripple reflects turbulence in the magnetosphere. The sky writes in light for our eyes and in radio waves for spacecraft. 2 different canvases, 2 different languages, one phenomenon. When a satellite passes above a storm, it records a dazzling interplay of frequencies, long descending whistles created by electrons sliding along field lines, short crackles marking sudden magnetic reconnection, low pulses tied to currents that circle the polar caps. In these emissions, scientists read the weather of space. The storms we cannot see the energy, we cannot touch the language of a planet whispering to its star. Invisible songs of other worlds. Auroral radio waves do not belong only to Earth. Jupiter sings more loudly than any planet, a roaring pulsing radio voice powered by both the solar wind and its volcanic moon, Io. Saturn hums with deep rhythmic notes tied to its rotation. Even distant brown dwarfs, failed stars drifting in darkness, emit auroral radio bursts that flare like cosmic heartbeats. Where there is magnetism, where there is plasma, there is a song. Earth's aurora is simply the one we can almost touch with our own sky. Why humans never hear the song. The irony is gentle and profound. The aurora creates one of the strongest natural radio broadcasts on our planet, yet humans cannot hear it for 3 reasons. The frequencies are much too low for our ears. They vibrate slower than any sound we can detect. The waves travel through space, not air. They need translation before they become sound. The ionosphere blocks them. By the time the waves reach ground level, they are turned away. We live beneath a silent concert hall, never hearing the orchestra playing above. Earth's magnetosphere as an instrument. Picture the Earth not as a planet but as an enormous musical instrument. The solar wind provides the bow. The magnetic field provides the strings. The electrons provide the notes. When the solar wind strikes, field lines vibrate like wires under tension. Plasma waves ripple like tones rolling through a cathedral. Currents crackle like a choir inhaling before song. The aurora is the visual performance, the painting. The radio waves are the acoustics, the melody behind the color. Together they form a symphony of space weather, a music woven from magnetism and light. The poetry of a planet's voice. In the quiet of night, standing beneath a sky that glows with emerald fire, you may feel as though the world is speaking. Perhaps ancient people sensed that even before radios existed. Perhaps they felt the presence of something that moved without wind, shimmered without flame, and carried meaning without sound. Today we know the aurora truly does speak, just not in a language our ears can hear. Its words are waves, its sentences are pulses, its accent is the curve of magnetic lines shaped by a turning world. The aurora sings in frequencies older than human hearing, sending its music across space towards satellites, toward probes, toward the quiet vacuum where no one listens. And yet the song continues, because the sky sings whether we hear it or not. On Earth, the aurora feels like a rare and delicate gift, ribbons of green and red drifting through winter darkness. But across the solar system, the lights take on forms so immense, so powerful, that our polar skies seem quiet in comparison. Auroras are not unique to Earth. They are the signature of magnetism everywhere. Where a world has a magnetic field, an atmosphere and a stream of charged particles, light appears. The colors change, the shapes change, the forces change. But the phenomenon is the same, a star touching a planet answering with light. Jupiter, the giant with a crown of thunder. If Earth's aurora is a whisper, Jupiter's is a roar. Jupiter's magnetic field is the strongest of any planet in the solar system. 20,000 times more powerful than Earth's. Where our aurora stretches a few hundred kilometers, Jupiter's spreads across entire planetary diameters. Seen from space, it looks like a colossal ring of fire encircling the pole, bright enough to outshine all other planetary auroras combined. The true source of Jupiter's auroral power is not only the sun, but a small volcanic moon named Io. Io erupts constantly, sulfur plumes blasting hundreds of kilometers into space. Jupiter captures that material, accelerates it, electrifies it, and sends it spiraling toward its poles in torrents of energy far greater than any storm on Earth. The result is an aurora that never turns off, a permanent storm, a glowing crown around a giant. While Earth's auroras pulse in quiet cycles, Jupiter's are a continuous symphony of power, the universe's loudest radio beacon, its brightest polar light, its most relentless spacefire. Io, the moon that sparks lightning in space. Io is the only moon known to generate its own auroral footprint on another world. As it orbits Jupiter, Io behaves like a dynamo motion plus magnetic field and electric current. A 4 million amp electrical circuit stretches between Io and Jupiter, glowing as it channels energy through space. At the point where Io's magnetic footprint strikes Jupiter's atmosphere, a bright spot appears, a luminous marker of an electric bridge between world and moon. It is like a lightning bolt frozen in place connecting a volcanic moon to a gas giant, a celestial power line stretching hundreds of thousands of kilometers. Saturn, the subtle, ghostly rings of light. Where Jupiter shouts, Saturn whispers. Saturn's auroras are softer, more ghost-like. They shimmer in ultraviolet like shifting curtains wrapped around the poles, more fragile in shape yet still larger than anything on Earth. Sometimes Saturn's rings even influence the aurora. Dust, ice and plasma from the rings drift into Saturn's magnetic field, creating faint arcs that flicker in alignment with ring particles. It is aurora shaped by architecture, a world whose jewelry alters its glow. During strong solar storms, Saturn's auroras flare, dramatically expanding until they resemble swirling hurricanes of light, curling into spirals round the poles. But in calm periods, they become gentle halos, thin, faint, perfect circles glowing on a golden planet. Uranus, the tilted enigma. Uranus is strange. It spins on its side, its poles pointing almost directly at the Sun for parts of its orbit. Its magnetic field is misaligned, tilted nearly 60 degrees offset from the planet's center. Auroras on Uranus are chaotic. They don't form neat circles or stable ovals. Instead, they flicker in unpredictable places, appearing as brief, wandering arcs far from where theory expects them to be. A tilted world creates tilted light, a reminder that the universe rarely obeys simple patterns. Where Earth and Jupiter have rhythmic auroral pulses, Uranus has flashes elusive, faint and strange. They are the lights of a world that lies sideways in the Sun, Neptune, the deep blue storm lights. Neptune's auroras are even more mysterious. They are faint even in ultraviolet. They appear rarely. They seem chaotic, like storms drifting through a deep blue twilight. Neptune's magnetic field is tilted and offset like Uranus's, but its atmosphere is colder, deeper, more distant from the Sun's breath. And yet when they appear, Neptune's auroras carry a quiet power, soft arcs of ultraviolet, glowing in the icy dark, shaped by winds that blow faster than any on Earth, up to 2,000 km/h. They are auroras born in the coldest, farthest reaches of the solar system, lights carried by winds stronger than any hurricane glowing on the edge of starlight. Brown dwarfs. Where auroras become stars beyond the planets lie objects stranger still. Brown dwarfs, the failed stars that glow dimly in infrared, too small to ignite fusion yet too large to be planets. Brown dwarfs generate auroras so powerful that they blaze in radio wavelengths detectable across light years. Their magnetic fields can be thousands of times stronger than Jupiter's. Their auroras are not gentle glows but cosmic beams, powerful enough to outshine entire planets. If you could see a brown dwarf's aurora with your eyes, it would look like a star wearing a crown of lightning. A halo brighter than any polar light in the solar system, powered not by the Sun, but by the dwarf's own internal engine of magnetism. These auroras bridge the gap between planets and stars, a phenomenon born in atmospheres yet strong enough to rival stellar flares. A cosmic reminder that light does not belong only to worlds like ours. A solar system painted in light. When we step back, a pattern emerges. Earth whispers in green and red. Jupiter thunders in ultraviolet and radio. Saturn glows in gentle rings of polar shimmer. Uranus flickers unpredictably in tilted arcs. Neptune pulses faintly in deep blue storms. Brown dwarfs blaze with magnetic fire like half-formed stars. Auroras tell us about magnetic fields, atmospheres, stars, moons. But they also tell us something deeper. Every world that can glow does glow. Every planet answers the Sun or its own internal fires with a signature written in light. The solar system is not a cold clockwork, but a gallery of luminous hearts, some enormous, some delicate, some flickering, some roaring, each speaking in its own color, its own rhythm, its own quiet song. Auroras are not just lights, they are identity, the breath of worlds. We tend to think of auroras as Earth's signature green curtains across winter skies, shimmering ribbons flowing around our magnetic poles. But two nearby worlds, Mars and Venus, experience their own versions of auroral light. They glow in ways both familiar and strange, carrying lessons about how planets evolve and what they lose along the way. These are not majestic polar crowns like those on Earth or Jupiter. They are fainter, quieter, sometimes hidden. But they are still auroras, light born from a star touching a world. And the differences between them whisper something deeper, a story of magnetic fields that faded, atmospheres that fled, and worlds that changed forever. Mars, a broken magnet, a patchwork of light. Long ago, Mars once had something Earth still possesses, a global magnetic field. Billions of years in the past, its core churned with molten iron, and moving currents, a dynamo strong enough to shield the young planet from the sun's fierce breath. With that shield came protection and atmosphere, surface water, the possibility of long-term warmth. But the Martian dynamo died. The core cooled and stiffened. The magnetic field flickered, then went silent. Today Mars has only magnetic fossils, ancient remnants frozen in the crust. Small patches of magnetism still linger beneath the surface like memories of a shield that once wrapped the entire planet. Auroras on Mars reflect this broken heritage. They do not form elegant polar ovals. They do not circle the poles at all. Instead, they appear as scattered local bursts, faint ultraviolet flashes glowing over regions where crustal magnetism remains trapped. A patchwork aurora for a patchwork field. During solar storms, these tiny magnetic pockets flare with brief glows. Not curtains, not waves, just sudden sparks across the night side of the planet. Each spark is a whisper of what Mars lost, and a reminder that without a living magnetic shield, the sun strips a world bare. The Martian atmosphere today is thin, less than 1% of Earth's pressure. Much of its ancient air was carried off by the solar wind over billions of years. What remains is fragile, delicate, vulnerable. The auroras of Mars are beautiful and bittersweet. They glow not because the planet is thriving, but because the planet is exposed. They are the lights of a world that once held oceans, now reduced to a desert beneath the unfiltered sun. Venus, a world wrapped in lightning without a shield. If Mars is the planet that lost its magnetism, Venus is the planet that never had one. Despite being nearly Earth's twin in size, Venus lacks a global magnetic field. Its slow rotation, one Venusian day, lasts 243 Earth days, means its core does not churn fast enough to generate a protective magnetosphere. Yet Venus still has auroras. Not the polar lights of a magnetized world, but a different phenomenon entirely, auroras born from the sheer force of the solar wind slamming directly into the atmosphere. When the sun erupts and a coronal mass ejection reaches Venus, the solar wind hits the planet's ionosphere with nothing to deflect it. The shock compresses the atmosphere, ignites electrical currents, and creates a glowing arc across the night side of the planet. The Venusian aurora is sometimes called a detached glow, a broad diffuse band of ultraviolet light stretching across the dark hemisphere. No poles, no ovals, just a global storm-driven shimmer. On Earth, auroras are guided by magnetic rails. On Venus, the solar wind paints wherever it pleases. This has consequences. Without a proper magnetic shield, Venus's upper atmosphere is constantly eroded ions, torn away, and lost to space. Over billions of years, Venus transformed from a world that may once have had oceans into a furnace planet wrapped in sulfuric clouds, trapped in a runaway greenhouse of unbroken heat. Its aurora is a light born not of harmony but of collision, a scar of brightness across a world overwhelmed. Two worlds. Two lessons. Mars and Venus, Earth's closest neighbours, show us two paths a planet can take when its magnetic protection fails. Mars lost its magnetic field long ago. Its auroras became isolated sparks over old magnetic scars. Its atmosphere thinned, its rivers dried. Cold and silence replaced warmth and weather. Venus never developed a strong magnetic shield. Its auroras became global flashes driven by direct solar impact. Its atmosphere thickened instead of thinning, locked into a heat trap of unimaginable pressure. The world became too hot, too heavy, too bright with sulfuric sunfire. Mars froze, Venus burned, and in both places auroras mark the cost. On Earth, the aurora is a celebration of balance, a living magnetic field channeling energy into harmless light. On Mars, the aurora is a memory, On Venus, the aurora is an injury. What other auroras teach us about Earth? When we look at the lights on Mars and Venus, we see echoes of our own future possibilities of what might happen if Earth ever lost its magnetic heartbeat. Without our shield, solar storms would strike the upper atmosphere directly. Atmospheric escape would accelerate. Radiation levels would rise. Satellites and surface life would face constant stress. Earth's auroras would no longer be polar curtains, but chaotic flashes like those on Venus, fragile signs of a sky under assault. Our magnetic field is not just an invisible dome, it is the boundary between life and loss. Mars and Venus show what happens when that boundary fails, the quiet consolation. Yet even in the strangeness of these alien auroras, there is a quiet beauty. Mars's faint sparks remind us that worlds carry memories. Venus's glowing arcs show that light can survive even in harsh, impossible places. Auroras are universal. Wherever there is a star, wherever there is a world that can hold an atmosphere, some form of light appears. Gentle or fierce, structured or chaotic, guided or scattered, the glow is the same message. Here is a place touched by starlight. For Earth, that message is wrapped in protection. For Mars and Venus, it comes with a cost. But in each of them, the universe paints with the same brush-charged particles, meeting atoms, turning darkness into color. A reminder that worlds evolve. Fields rise and fail, atmospheres grow and disappear. But the dance of light continues. Even on planets like our own, changed, wounded, or lost, the aurora still finds a way to shine. The aurora feels like a piece of poetry, soft light drifting in the dark. But behind its beauty lies one of the greatest laboratories in the universe. Every ripple of green, every flicker of violet, every sudden brightening is the visible trace of a science far older than planets. Plasma physics, the study of matter in its most energetic electric-magnetic form. 85% of the visible universe is plasma. Stars are plasma. Nebulae are plasma. The solar wind is plasma. Galaxies are shaped by magnetic fields threading through plasma. And yet, one of the most accessible plasma laboratories lies just above our heads, glowing on cold nights near Earth's poles. Auroras are not just beautiful. They are lessons about how the universe works. Auroras as plasma made. Visible. Plasma is the fourth state of matter atoms stripped of electrons free to flow electrically. It behaves unlike solids, liquids, or gases. It conducts electricity, it generates currents, it responds dramatically to magnetic fields, and the aurora is plasma interacting with the atmosphere. In that boundary where solar plasma meets Earth's air, we watch something profound, charged particles spiraling along magnetic lines, electrons accelerated to high energies, waves bouncing back and forth through magnetic corridors, collisions transforming raw energy into color. If you want to understand plasma, you study the aurora. Not in textbooks, but in the sky, the magnetosphere. A giant plasma experiment. Earth's magnetosphere is a plasma machine the size of a planet. The solar wind shapes it. Magnetic fields guide it. Particles fill it with invisible storms. Auroras tell us what is happening in that giant machine. A sudden brightening means electrons have been injected into the atmosphere. A rippling arc means a wave has passed through the plasma sheet. A surge of light means magnetic fields have snapped and reconnected. Every shape the aurora makes, every curve, every flicker, every trembling edge is physics expressing itself in color. We watch light, but we learn plasma. Reconnection, the universe's way of releasing energy. One of the greatest mysteries in astrophysics is magnetic reconnection. The process where magnetic fields break and reform, releasing enormous amounts of energy. Reconnection shapes solar flares, pulsar winds, black hole jets, galaxy-scale magnetic structures, and the aurora above Earth. When the magnetotail Earth's long magnetic wake stretches too far, its field lines snap and reconnect. Energy stored for hours is released in seconds. Electrons are hurled toward the poles. The sky brightens violently. Arcs split. Curtains race. A reconnection event is not just a light show. It is the same process that powers solar storms and flares millions of times stronger. Scientists study Earth's auroras because reconnection here is small enough to observe and large enough to matter. What we learn from auroral storms helps us decode the engines of stars. Fusion research learning to bottle a star. Far from the polar night in laboratories on Earth, scientists try to recreate the power of the sun fusion. Fusion requires controlling plasma hotter than the core of a star plasma that writhes, twists, and fights confinement. Magnetic fields are used to hold its shape, stabilize it. But plasma is unpredictable. It forms filaments, it erupts into turbulence, it triggers reconnection bursts that can damage reactors. To understand plasma stability, researchers look upward. The aurora behaves in ways astonishingly similar to confined plasma in fusion machines, spiraling motions like those inside tokamaks, wave-particle interactions that alter energy flow, sudden bright arcs analogous to plasma disruptions, field-aligned currents resembling the currents in fusion devices. The sky becomes a teaching tool. Auroras help scientists refine theories, test computer models, improve magnetic confinement, and bring controlled fusion one step closer. Every green flicker is not just light, it is data, plasma waves. The universe is invisible music. Auroras are shaped by plasma waves moving through Earth's magnetic field, Alphen waves carrying energy along field lines, Whistler modes spiraling electrons into the atmosphere, chorus waves that sound like birds when translated into audio. These waves behave the same way in stars, nebulae, and galaxy clusters. By studying the aurora's waves, we learn how energy moves in the universe, how stars heat their outer layers, how solar winds accelerate, how cosmic rays travel between stars, how galactic magnetic fields transfer momentum. In the shimmering sky, we see echoes of phenomena playing out across billions of light years. Earth becomes a miniature galaxy, a place where cosmic rules reveal themselves in local light. Auroras as natural particle accelerators. Scientists used to believe only enormous structures, supernova shocks, black hole jets could accelerate particles to high energies. But Earth does it too. The auroral zone is a natural particle accelerator. Electrons are energized upward of 10,000 eV. Beams form along magnetic lines. Plasma cavities pull particles into narrow jets. These same mechanisms appear around pulsars, black holes, and magnetized exoplanets. By measuring auroral electrons, we model cosmic accelerators too distant to visit. A faint green arc in the sky is powered by the same physics that lights the Crab Nebula. Why the sky is a teacher? Because the aurora is accessible. You do not need telescopes to see it. You do not need exotic machinery. You do not need billion-dollar experiments. You need darkness, patience, cold air, a willingness to look up. The universe has hidden much of its physics in unreachable places, inside stars, around quasars, between galaxies, but some of it, some rare generous fraction, is visible from Earth's surface, in green, in red, in violet, in drifting curtains that carry the blueprint of cosmic behavior. The sky is not just decoration, it is instruction, for as long as the field holds. As long as Earth has a magnetic heartbeat, auroras will continue to teach us how stars release energy, how plasma flows through space, how magnetic storms erupt and heal, how galaxies thread themselves with invisible currents. The aurora is a cosmic chalkboard, the universe writing notes in light. If you ever stand beneath that glow, know that you're looking at one of the most elegant physics lessons ever offered, quiet, gentle, and yet vast enough to explain how stars burn and how galaxies breathe. The sky is teaching us. We are still learning. Long before auroras were diagrams of plasma and magnetism, long before scientists charted the solar wind or satellites listened to the sky's radio pulse, the northern and southern lights were something else entirely. They were stories. Across thousands of years, in lands wrapped in darkness and snow, people looked up at the same drifting curtains we see today, and instead of equations, they saw meaning. They saw presence. They saw messages. The aurora is science, but it's also memory, a bridge between sky and soul, lights as ancestors. The northern belief among many indigenous peoples of the Arctic, the aurora is not just a glow, it is a presence. For the Sami people of northern Europe, the lights Gwovsahasat were treated with deep respect. They were not to be mocked or whistled at. To show disrespect invited danger. To walk quietly under the lights was to honor something older than the world itself. In parts of Alaska and Canada, the Inupiat and Inuit held a tender belief the lights were the spirits of ancestors playing in the sky, dancing, laughing, gathering, watching over the living. Imagine a long winter night, the cold biting the edges of your breath, and above you shimmering arcs drift like the footsteps of those who came before. In that moment, the sky is not distant, it is family. The aurora becomes a reunion, sky lanterns of the departed across cultures. Far from the Arctic, other cultures also saw the lights as messengers between worlds. In Finland, people saw them as firefox sparks, flames trailing from the fur of a magical creature racing across the snowfields. In Greenland, the lights were believed to be the souls of children playing with a walrus skull, their laughter frozen into the colours of the sky. In medieval Europe, red auroras were sometimes interpreted as signs of great battles, the heavens reflecting the bloodshed of distant lands. In Japan, couples still hold a quiet, hopeful superstition. A child conceived beneath the aurora is believed to be blessed with good fortune. Even in modern Tokyo, people travel north hoping the lights will give their future children strength. Different stories, different emotions, different worlds, but the same sky. When the lights were spirits of animals. For many northern cultures, the aurora was alive, not human, but animal. The Algonquin peoples believed the lights were the great creator's fire burning to guide the living. The Menominee of Wisconsin said the lights were torches held by giant fish in the northern lakes, warning humans not to venture too far onto the ice. The Cree told of the dance of the spirits, an elegant swirling motion of celestial beings moving through the night like silent hunters. For the Tlingit in Alaska, the lights were the glowing scales of salmon swimming through the sky. To see an aurora was to witness the movement of a world that mirrored Earth's animals, but made of light. The lights that sing without sound. Many stories speak of the sky whispering. On rare nights during the strongest storms, some people report faint rustling sounds like snow grains sliding across a frozen lake or static crackling in dry air. Indigenous traditions long held that the aurora made sounds and that certain people, elders, shamans, hunters, could hear them more clearly. Western science long dismissed this. Then, decades later, microphones began capturing faint crackles during major storms. Perhaps the sky does whisper after all. Perhaps the old stories knew something we are only now rediscovering. The red omens fear in ancient skies. Not all stories were gentle. In China during the Song dynasty, red auroras were seen as warnings, heavenly banners signaling coming change. In ancient Rome, red skies were omens of war, the heavens reflecting turmoil on earth. In Polynesia, rare Southern Lights events were sometimes interpreted as ancestral fires, signals of upheaval across the ocean. When auroras appeared far from the poles, they arrived as strangers, unexpected, bright, impossible to ignore. To ancient eyes, these lights were not accidents, they were messages, and messages often meant consequence. Auroras as bridges between worlds. Nearly every culture and every place touched by aurora shares one theme: the lights are a bridge. Between living and dead, between earth and sky, between the human world and the realm beyond. In Norway, the northern lights were believed to be the reflections from the shields of Valkyries, the warriors who guided fallen heroes to Valhalla. In Iceland, the lights were said to ease the pain of childbirth, a comforting glow in the darkest months. In Estonia, hunters believed the lights were horses of the gods, their manes trailing sparks across the sky. In each story, the aurora connects something low with something high, something temporary with something eternal, something human with something cosmic. Light becomes language. Why we tell these stories? Why do humans give meaning to the sky? Because darkness makes us listen. Because color makes us hope. Because we long to understand the world not just with knowledge, but with feeling. A scientific explanation can tell you why green appears at 100 km, why nitrogen glows purple, why the solar wind spirals along magnetic lines. But a story tells you something else: why the light matters. Science explains the aurora's motion. Culture explains the aurora's meaning, and meaning is what we carry with us. The modern world still looks up. Even today, in a world of satellites and equations, people still gather under the lights and feel something ancient stir in them. Tourists cry softly on Norwegian fjords. Elders watch quietly from frozen lakes in Canada. Children in Alaska press their hands to the window, believing the ancestors are waving back. Astronauts see the aurora from above and describe it as a living wonder. Some lights belong to physics, but others belong to us. The aurora is a story we have told for thousands of years, a story written in color, retold in whispers carried through generations. And whether we call it science or spirits or ancestors, the truth remains the same. The light is a gift. A reminder of our place between earth and sky. A reminder that meaning is something we create and beauty is something we share. The human story of the aurora is as vast as any plasma storm, as luminous as any curtain of green, and as enduring as the night itself. Every aurora begins quietly. Long before the sky erupts in sweeping curtains or racing spirals, Long before the greens sharpen into electric edges or the reds bloom like distant embers, there is a single faint glow, a patch, a smudge of light in the darkness, the first whisper that a storm is building behind the horizon of night. This is how every auroral substorm begins, with a subtle shimmer, almost timid, as if the sky is testing its own voice. But beneath that softness lies a drama as tense and powerful as any storm on Earth. A substorm has 3 acts: the growth, the expansion, and the recovery. 3 movements of a cosmic heartbeat, tension, explosion, resolution. The growth phase. The silent tightening. It begins an hour or 2 after nightfall in the high latitudes, when the magnetotail Earth's long magnetic wake stretches behind the planet like a drawn bowstring. The solar wind pushes from the day side. The magnetotail pulls from the night side. Energy accumulates, tension builds. But from the ground, almost nothing seems to happen. A faint arc appears low on the northern horizon, steady, unmoving. A quiet pale band of green that seems frozen in place. This is the growth phase, a time when the magnetosphere is loading with energy, but the sky is holding its breath. The quiet arc tightens, its edges sharpen. A second arc may form above it, thin as a brushstroke. The air is still, the night is calm. Even experienced aurora watchers know that this is the moment to wait, the moment before everything breaks open. Deep in the magnetotail, far beyond the reach of human senses, magnetic fields are bending toward each other. Drawing closer, preparing to snap, the sky is gathering strength. The expansion phase, the breaking of the bowstring. Then it happens. A bright spark on the quiet arc, a sudden bead of light like the first crack in a sheet of ice. The arc brightens all at once, its green deepening into a vivid electric glow. It curls, splits, and begins to race overhead. This is magnetic reconnection, the moment when stretched tail fields finally snap and rejoin, releasing stored energy in a rapid, explosive burst. To the eye, it looks like the sky has suddenly awakened. Arcs ripple upward, curtains unfurl, rays shoot toward the zenith like glowing pillars, columns of light twist in silent spirals. A river of green pours from one horizon to the other. The aurora expands with startling speed, moving so quickly that the mind struggles to keep pace. This is the expansion phase, a few minutes when the night transforms into a living storm of color. Some arcs shimmer like silk caught in a breeze. Others explode into a burst of violet at their tips. Sharp teeth of light flash along the lower edges, snapping like luminous waves. The world below remains silent, but the heavens are roaring with invisible energy, electrons accelerating along magnetic rails. Plasma waves bouncing through the magnetosphere, electric currents surging across continents. Earth's entire magnetic system ringing like a bell struck hard, and yet not a sound reaches your ears. You only see the motion, the great unfolding. The substorm reaches its peak, a storm of light, born from a storm of magnetism. The great unfolding, a sky in motion. At the height of a substorm, the aurora becomes a full symphony of motion. The arcs dissolve into curtains. The curtains split into ribbons. Ribbons twist into swirling helixes, as if stirred by invisible hands. Colors deepen, green turning into emerald violet, sharpening along the edges, red flickering high above like ghostly embers. Sometimes the sky seems to open a corona forming overhead, all rays converging at a single point above you like spokes of a celestial wheel. It feels as though you are standing inside the aurora, not beneath it. The magnetosphere is pouring its energy into the atmosphere like a river bursting through a narrow canyon. The light is not random. It is structured, guided by field lines, shaped by currents, a choreography dictated by physics performed by particles. But in the moment, all you feel is wonder. This is the aurora at full strength, wild, radiant, impossibly alive, the recovery phase. The long exhale, and then just as suddenly as it erupted, the storm begins to soften. The brightest arcs fade to pale green. The racing curtains slow. The sky loosens its grip on the moment. Earth's magnetic field is settling again, like a shaken instrument returning to quiet tuning. This is the recovery phase, the long exhale after the held breath and sudden burst. The sky becomes gentle once more, faint ripples drift overhead. Small patches flicker like embers cooling in a fire pit. Thin rays appear and vanish without urgency. Sometimes the aurora collapses into a simple dim haze, a soft green glow that lingers on the horizon like the memory of a storm. Other times the lights disappear entirely, leaving behind only stars and the feeling that something extraordinary has passed. The magnetosphere relaxes, its tension is discharged, the cycle is complete. But the night is not empty. The silence after a substorm carries its own beauty, the quiet satisfaction of a sky that has finished telling a story, a drama older than humanity. For thousands of years, people watched these phases without knowing their cause. They saw the tension, the eruption, the fading, and gave it mythic names: the sky waking the heavens, dancing the spirits returning home. Today we understand the physics, the loading of the magnetotail, the reconnection burst, the release of electrons. But the emotional truth remains unchanged. A substorm is a drama, a lifting of curtains, a bright crescendo, a gentle closing. A cycle of tension and release woven into the magnetosphere's endless rhythm. Every aurora we see, from a single faint arc to a sky-filling storm, begins with that first glow, quiet, hesitant, the softest hint of what is about to unfold. A whisper that becomes a roar and then returns to whisper again. Tonight, as you prepare to rest, the universe continues its gentle conversation. Above you, beyond the comfort of walls and windows, Earth is wrapped in the soft glow of magnetism and starlight, a living connection between our world and the sun that warms it. Every aurora you've imagined across these chapters, every silent ripple of green, every whisper of violet wandering across a frozen horizon, is part of a story billions of years old, a star breathing, a planet listening, and our life unfolding in between. In the darkness of space, the sun is burning still, not angrily, not in fury, but steadily, patiently, like a heartbeat we can trust. Its light travels across emptiness, touches Earth's magnetic shield, and is transformed into color so that even night remembers the day. And the Earth responds with grace, bending, guiding, shaping that energy into rivers of light that glide through polar skies as though the planet is exhaling beauty. The sun sends its pulse. The Earth answers in green, a harmony older than oceans, older than continents, older than the first breath any creature ever took. You are part of that harmony as surely as a leaf is part of a tree, or a tide is part of the moon's pull. Human hearts beat to rhythms shaped by sunlight, our days, our seasons, our warmth, our sleep. Even as you close your eyes, your body remembers the star that shaped you. The iron in your blood was forged in ancient suns. The calcium in your bones was built from stardust. The light falling on your skin this morning began its journey in the sun's core before any human existed. You're a child of this star, sleeping on a world that learned to glow back. And tonight, as the auroras drift in quiet arcs around the poles, they are not just lights in the sky, they are reminders. Reminders that Earth is protected. Reminders that the sun is generous. Reminders that our place in the cosmos is both fragile and wondrous. Above Antarctica, a red veil is shimmering. Above the Arctic, green curtains breathe like the lungs of the night. Above the equator, the sky is dark and calm. Everywhere, the planet turns slowly, unhurried, ancient, sure of itself. You are turning with it, held in the arms of gravity, carried through space, cradled between a sun that burns and a universe that watches quietly. So as this chapter closes, as the final glow of this long journey fades gently into dusk, let your mind soften. Let the day release its weight. Let your thoughts settle like snow falling on still water. Let your breath follow the rhythm of the world, slow, steady, glowing in its own small way. Somewhere far above the planet is wrapped in a soft auroral crown. Somewhere deeper still, the sun is preparing tomorrow's light, and somewhere right here in this quiet moment, you're part of all of it. Good night, Earth. Good night, sun. Good night to the colours that wander the poles, to the magnetic heartbeat that keeps our sky alive, to the starlight that raised us, to the universe that holds us. Good night, and rest in the gentle harmony of a planet and a star that have been dancing since the dawn of time.